Hello, my shimmering stars. I welcome you all to this awesome platform of PW English. Students, as you all know, this is Victory Batch. So, I am Shaurya, your chemistry teacher, and we are going to start our chapter Some Basic Concepts of Chemistry. Students, as Victory Batch says, the harder the battle, the sweeter the victory. So now with this quote, we will start our first topic. Students, as the name suggests, some basic concepts of chemistry. So I would say that there is a word basic in this. This defines us and reminds us of those classes, the previous classes which we have studied. Like class 10th. In class 10th, we have studied about matter in our surroundings. So, from that portion, we are going towards our 11th portion. From 10th towards 11th. So, I am going to tell you every basic detailed of the chapter. First of all, the thing that arises in everyone's mind is the subject chemistry. Students, chemistry is the branch of science that deals with the study of composition, structure, and properties of matter, and also about the changes that matter undergoes in different conditions and the various laws that govern those changes. So, students, chemistry plays a vital role in science. Students, it plays a vital role in healthcare products, applications in war, applications in industry, applications in food. So, in our day-to-day life, chemistry has an important role. So now moving towards this, in our surroundings, when we look around, we'll look around a lot of things, a lot of objects. The most common object which a student observes in its classroom is the duster. Well, duster is a kind of solid object, right? Okay, now let me tell what is the glass of water. Glass of water is a liquid, right? So water comes under the category of liquid phase. Now students, these substances which we look around in our surroundings are all matter. Now what is matter? Matter is a substance that possesses mass and occupies space. One more thing that defines this more accurately, I would say, is we can eventually feel with our senses, right? So what would be the definition of matter? I would say matter, it is a substance. It is a substance which possesses mass and occupy space and can be felt by our senses. So as I told you, example of duster, of water, we can take more examples like chalk. We have gases around us. All these are matter, students. You know what? Matter can be classified into two basic categories. The number first one is the physical classification and the next one is the chemical classification. So when we classify them, when we classify matter, classification, it is the physical one and the chemical one. Students, when we study about physical classification, physical classification tells us about states of matter. Now, what are states of matter? The most common and the famous example is in front of you. This is solid, liquid and gas. Students, when we take a ice cube from our freezer in our home, in our kitchen, we take it out and we put it into a bowl. It starts melting. When that liquid is kept on a stove and is heated, it converts into vapors. So what is this? These are states of matter. The ice cube that we took from the freezer is a solid. Like the water in which it is converted was liquid, and when then it was heated, it converted into water vapors. That water vapors was gaseous form. So what we observe, students? We observe these states of matter in our day-to-day life, right? Solid, liquid and gas. Now moving towards the physical classification in detail, first of all we'll learn about solid. First of all, we will learn about solid. If I talk about solid, solid is an object in which what we can observe that particles in solid are so tightly packed. For example, this is my first particle, this is my second, third and fourth. This is the first layer. Now, how is the second layer formed here? The second layer is similarly just like the first layer. They are so tightly packed with each other like this way. 1, 2, 3, 4. Now, the third layer is in such a form. Now, what you can see, by just looking at the example, I can observe that there are some particles. Let us say these are A particles or B particles. Okay, let us say A, B kind of particles. If I say A, B kind of particles, they are so tightly packed. This is my A particle, this is my B particle. They are so tightly packed that they cannot move from their mean position. They will only vibrate along its mean position like to and fro, just like this. They can't move from one position to the another position. And what is the reason behind this? That they have strong forces of attraction. Do remember that. So the first point which we need to write here is the particles are tightly packed. Particles are tightly packed, students. The next point which we have to remember, that there is a strong forces of attraction. Moreover, we can say they have a definite shape and definite volume. That these are the basic things: definite shape, definite volume. We have studied these in class 10th. Right? But in 11th, the most important thing you need to remember is the force of attraction and the force of repulsion, right? So, next point is force of attraction. Force of attraction is very, very strong, due to which they are unable to move, students. Due to which they are unable to move. Now, coming towards the third most point, I would say, in the case of solids, there is very, very less forces of repulsion, or I would say the tendency to escape each other. How to escape each other? If one particle is escaping from another particle, they attain a distance. They are at a farmost distance, and if there is a strong force of attraction, they are attracted and they are close to each other. In solid, they have zero, very, very less forces of repulsion. So, forces of repulsion, which I already told you, to maintain distance between each other, right? In case of solid, it is very, very less, which is almost negligible, students. Okay, this was all about solid. You can even add more points like definite shape and definite volume. Okay, now moving towards the next case. The next case is our liquid. Okay, if I talk about liquid, now let us see its structure first of all. In the case of liquid, the particles are at a distance from each other, but not at a farmost distance. They are at a little bit distance from each other. For example, if I say this is my first particle, then this is the second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one. So what are the things that I'm observing here, students? I am observing that, number first, the particles are quite at a distance from each other, but not far. They are close but not far, but at a distance from each other. The second point which we observe here is the forces of attraction. See, in the case of liquid, both the forces act, forces of attraction and forces of repulsion. There is a forces of attraction, that's why they are attracted, and there is forces of repulsion, that's why they are not so close attached. They are at a little distance because both the forces act. So I would say the forces of attraction in the case of liquids is less than solids but more than gas, right? Okay, now coming towards the third most point, that is the forces of repulsion. So if I talk against gases, I would say liquid, has a less force of repulsion as compared to gaseous form, and I would say it has more repulsion as compared to the solid form. So the third most point is force of repulsion is more than solids but less than liquids. Okay, so students, this was all about liquid state. Okay, I would say that they have a definite volume, but they don't have a definite shape. For example, if I take a beaker, and if I transform that the liquid from one substance into another substance, it would occupy its shape. So shape is not certain for the liquid case. Hence, its volume is certain. That means its volume is definite, but not the shape one, right? So, the third thing that we talk about is our gaseous form. If I talk about gaseous form, first of all, let us draw its structure. And while drawing its structure, we can easily tell the particles are at a farmost distance. For example, this is the first particle, it's the second, it's the third, like this. They are at a distance. So you can easily observe these things, like solid, they are very close. In liquid, they are at a distance, but in gaseous, they are at a farmost distance from each other. So when they are at a farmost distance from each other, first thing we can easily say that they have a very strong forces of repulsion. And how are the forces of attraction? They are very less. So first of all, the very first point which we are going to write, particles are far, very far, right? The second most point, students, that I am going to write here is the forces of attraction. So the forces of attraction is very less, very less. And the very last point, students, I would say that the forces of repulsion. So the forces of repulsion are very strong. So students, this was all about the physical classification, right? So if I say about the definite shape and definite volume, in the case of gases, there is no definite shape, no definite volume. In the case of gases, right? So this was all about the physical classification of matter. Now we are proceeding towards the chemical classification of matter. But before that, let me tell you that in the case of physical classification, we observe that these three forms, these three states of matter are interconvertible. That means that we can say that solids can be converted into liquids, liquids can be converted into gases, and gases can be converted into solids, and vice versa. How I am saying that liquids can further back be converted into solids, solids can further back be converted into gases, and gases can further back be converted into liquid. How can this be possible? In class 10th, we have already studied that while heating and cooling, we observe such situations. When I take ice from the freezer and keep it in a bowl, it converts, right, into what? Into water. When I boil that water, it converts into what? It converts into gaseous form. Okay, so these are all things we need to understand, that these three states of matters are interconvertible into each other. Now students, coming towards the chemical classification of matter. This is our chemical classification. Okay, if I talk about chemical classification, the very first thing arises is that it is classified into two basic categories. One is pure, another one is mixture. So by looking at the words, you can easily identify what do you mean by pure and what do you mean by mixture. Mixture is something in which something is mixed, right? And pure is something which is pure and something is not added into it, right? So these are the basic things when we listen to a word and we could think about it. So first of all, I would say that when we classify matter according to the chemical classification, we observe the pure substances. Pure substances are further classified into elements and compounds, and students, elements are the one of the kind. How I am saying that? In elements you can see only one kind of matter, only one kind of atom. How I can say that? Example carbon, example hydrogen, okay, example oxygen, you can even write that. Only one kind, only carbon, only hydrogen, only oxygen, only sodium, only magnesium, only one kind of atom. When we observe that, that is referred to as an element. And element, students, further is classified into three basic categories. First is metals, second is non-metals, and third one is, students, metalloids. So I would say that if I classify them into elements, then it is classified into metals. The second one is non-metals, students, and the third one is metalloids. Now, what are metals, non-metals, and metalloids? If I speak about metals to you, metals are the ones that are good conductor of heat and electricity. Metals are the ones that are lustrous. You have studied in class 10th the chapter metals and non-metals. Well, that is what metal is. It is lustrous, it is good conductor of heat and electricity. You know, it is malleable, it is ductile. What is malleable and ductile? Malleable are the ones that can be hammered into thin sheets, and ductile are the ones that can be converted into wires. For example, copper, magnesium, iron, these are metals, right? Now, coming towards non-metals, I would say non-metals are the one that are poor conductor of heat and electricity. You know, so they are not malleable, not ductile. We observe these things in non-metals. While coming across towards metalloids, metalloids are the ones that exhibit the properties of both metals as well as non-metals. So these were the basic things that we studied in the class, 10th. If I take example of metalloids, I would say that metalloids can be antimony, bismuth, arsenic, right? So this was all about elements. If I come towards the second category of pure substances, that is compounds. Compounds are the one which contain two or more than two atoms. Compounds, they are the one which contain two or more than two kinds of atoms. See, if you find only a single atom, that is known as element. But when you find two or more than two elements which are combined together, they are known as compounds. Students, compounds can be further categorized into organic and inorganic. They can be further classified into organic and inorganic. Organic compounds are those in which we study about hydrocarbons. Now, what is hydrocarbons? You will observe the hydrocarbons chapter in class 11th only. Hydrocarbons are the one in which we observe carbon as well as hydrogen. This is the basic necessity condition. Carbon and hydrogen should be present. Other than that, any other element can also be there. But if only carbon is present, it cannot be categorized into organic compounds. Do remember that. So, organic compounds are basically derived from animals and plants. But if I talk about inorganic compounds are the one that are derived from minerals and rocks. Clear? So, this was all about the compounds category. Now, moving towards the mixture. As I know, mixture itself tells us that something is mixed. It is further classified into homogeneous and heterogeneous. As we are a science students, whenever you are studying any of the topic, do remember that. Kindly take the word. If it is splitting into two parts, do that. It will make your concept easy and you will remember it here and you'll never forget it. Some people, what they do, they just keep again and again writing and learning and after few times they just forget it. when you understand any concept, you grasp it properly, you know, and then you become stronger, and then you remember that. So it will help you a lot. So try to understand things instead of, cramming it. So first thing is homogeneous mixture. As I told you, please split it into two parts. If I split it into two parts, I observe homo. Homo refers to what? Same. Homo refers to same. And if I speak about heterogeneous, hetero refers to different. Now what I meant by same and different? See, if something is present in uniform concentration or same concentration throughout, that is known as homogeneous mixtures. And if something is present in different composition throughout, that is referred to as heterogeneous, right? If I talk about homogeneous mixture, one of the examples which we observe is basically sugar in water, salt in water, okay? Example is sugar in water. The next one is salt in water or air, I would say. Why air I am saying? Because air is basically comprised of gases which are present in uniform concentration throughout. That's why it lies under the category of homogeneous mixtures. If I talk about heterogeneous mixture, one of the most common example is smoke. Other than that is oil in water, right? So heterogeneous, we have two cases like oil in water, where the concentrations are not uniform. The second most example I told you is smoke. So students, this was all about our chemical classification of matter. Okay, now moving towards the next topic, that is properties of matter. Now we have studied about the classification of matter. Now comes the properties. Now comes the properties of matter. Students, if I talk about properties of matter, what is the basic thing that I observe here? I see that the properties of matter can be of two types. One is the physical property, another one is the chemical property, okay? One is the physical property. Okay. The second one, students, is the chemical property. Okay, if I talk about, students, physical property. What are physical properties? Physical properties are the ones which we can observe and in which the identity is not lost, in which there is no chemical reaction. Okay, you can see that the substance remains the same throughout. So I would say that please do write it, or you can underline in your NCERTs. Physical properties, these are the ones which do not lose their identity, and no chemical reaction occurs here. Okay, example I would say density, volume, boiling point, melting point. These are the examples of the physical properties. Now coming towards the next one, that is the chemical properties. Chemical properties are the one in which reactant is being converted into the product. That means a chemical reaction is taking place. And when a chemical reaction is taking place, students' identity is lost of the reactant. So I would say the chemical properties are the ones in which chemical reaction occurs and they lose their identity, okay, when they are being consumed. So students, these are all about chemical properties in which you can add a chemical reaction occurs, right? Okay, so students, this was all about the properties of matter. Now, how can we measurement? How can we do the measurement of these properties, of these physical properties, basically, which we can observe, which we can think without any chemical change, right? So, if I see here about the physical properties, we talk about the measurement and how is measurement done. For example, if I say that I am living in my home and I want to eat some fruits or some vegetables, so what I do is I move from a distance, I move 15 meters at a distance, and I go to another place, and what I see is there is 15 meters or 15 kilometers I'm using. 15 here refers to as a number, and kilometers or meters refer to as a unit. So to measurement of a physical property, to measurementize a physical property, we need to understand the basic term, that is unit. A unit is a standard reference with the help of which we can measure any of the physical property very easily. Like we kept for distance, we kept meters, kilometers, so that we can calculate them and we can tell. For time, we have kept seconds, minutes, hours. These all are units which we have kept as a standard to understand, to measure all the physical properties around us, right? So students, now if I talk about unit, as I have explained you, unit can be further categorized into three basic categories. The number first is the basic units, second one is the fundamental units, and third one is the derived units. If I talk about the basic units, there are basically 7 basic units. You need to please star mark this situation, I would say, or you can put a box here. In your NCRTs also, there are 7 basic units. What are these 7 basic units? The number first is length. The second one is mass. The third one is time. The fourth one is electric current. The fifth one is thermodynamic temperature. Next one is amount of substance. And the next one is luminous intensity. So these are the basic units that we have to learn, right? These 7 basic units have particular symbols for them. How can we represent them? To represent length, we use small letter L. To represent mass, we use small letter M. To represent time, we use small letter T. To represent electric current, students, we use I. It is capital I. To represent thermodynamic temperature, we use capital letter T, right? To represent amount of substance, this is very important. It is represented by small n, and you are going to study it. It is about mole concept. In this only chapter, it is the most important and most asked topics, mole concept. So we'll study this there, okay? We represent it by small n, right? Then comes the luminous intensity, that is represented by I to the base V. Clear? Now, these all are given some units. Like length is given some unit, which is meter, which is referred to as the standard reference with the help of which we can measure the quantity, right? So for length, what is the SI unit? Meter. For mass, what is the SI unit? Kilogram. For time, what is the SI unit? Second. For electric current, what is the SI unit? Ampere. For thermodynamic temperature, what is the SI unit? Kelvin. For amount of stars, what is the SI unit? Mole. For luminous intensity, what is the SI unit? Candela. Students, now these units also have a particular symbols. We don't write the big names. We just use the symbols to represent them. For meter, the symbol is small m. For kilogram, the symbol is kg. For second, the symbol is only small letter s. For ampere, the symbol is capital A. For Kelvin, the symbol is capital K. For mole, it is MOL, and for candela, it is CD. So these were the 7 basic units that you need to understand. Students, now comes the second category, that is the fundamental units. That is the fundamental units. Now, what are fundamental units, students? Fundamental units are the ones that cannot be derived from any another units. They do not depend on any of the unit. They are independent. Can't be derived can't be derived. We cannot derive these from any another units, from any units. So these are the fundamental units. Fundamental units are basically the unit of mass, the unit of time, the unit of length, right? So now next comes the types of unit which are referred to as the derived units. Derived units are the one that can be derived, from the basic units. For example, if I take an example of area. Students, if I talk about area, if I consider about square, what I see? Square has sides, equal sides, right? And if I say that each side has a length L, right, or you can say A, when we consider this in mathematics. Don't worry, in mathematics there are some concepts that students feel that it's very tough, and in chemistry also, in numerical portion, ma'am, how we'll do that? Our maths is very weak. So don't worry, I am there for you, and the maths which you need in chemistry, I am going to explain you. So no need to worry, just you need to understand it, need to make notes by hand. First listen from me and then write accordingly, and just practice, because when you practice, that practice will leads you towards the victory. Clear? So practice is the most important, right? Now see, I am talking about area, and if I talk about square, what is the formula of area? It is length into length. And now only we have studied, you can see in this case, length is one of the basic unit, and when I multiply one basic unit into another basic unit, that means I am deriving something. So hence it comes under derived units. Are you understanding? If I am only talking about length, that is our basic unit. But if I am talking about length into length, that means I am deriving something. And when I am deriving something from the basic units, they are referred to as derived units. So here one of the another example I would say is volume. In the case of volume, what is the formula? Length into length into length. Right? Yeah. Otherwise, I would say length into breadth into height. All you can say is this. Right? So that is volume. Here also it is derived. Why it is derived? Because length is a basic unit. And when we multiply one basic unit into another, into the third one, it is the derived units. Now let us read this. What is given here? The units of all other physical quantities are derived from those of above quantities which we have studied already. Right? These units thus obtained are derived units. Area, volume, these are now derived units. Some common physical quantities and their derived units are also given to you in this following table. Now let us see that. The number first is area, which I've already told you. Students, it has a formula. What is the formula? Length into length. Now coming towards volume, I already told you its formula is length into length into length. Now coming towards density, the most easy formula which we have started in the small classes, and if you have not started, no need to worry, you are studying now, right? So density formula is mass by volume, right? What's its formula? Mass divided by volume, right? Okay students, now let us see the next case, that is velocity. Velocity is distance upon time. You have studied it in physics also in class 10th. So it is distance upon time, right? Okay, coming towards the next, acceleration. To derive acceleration, first you need to calculate velocity. So when you calculate velocity, just divided by time, you will get acceleration. So what is the formula of this now? Okay, its formula is velocity divided by time. Okay, now coming towards the next part, that is our force. What is force, students? Force is basically refers to as mass into acceleration, right? Force is our mass into acceleration. And if I talk about pressure, pressure is force upon area. So first you need to calculate force for that, right? Okay, now if I talk about the units here, first of all, if I talk about area, as you know, length into length. First tell me, in the basic unit, now we have seen that length has a SI unit, which is basically meter. Length has an SI unit, which is meter, right? So SI unit, the international system of units, we have studied just right now. The 7 basic units are those, right? So meter into meter, all I would say is meter square, right? The very first one is meter square. If I talk about volume now, see, meter into meter into meter. What is this now? Meter into meter into meter is cubic meter, right? So it has unit as cubic meter. Now students, coming towards the density, mass by volume. First you need to understand mass. Mass we have already studied in the basic unit. It is kg. Its unit is SI unit is kg. And volume, its unit we have already calculated, cubic meter. So hence we can write here kg per cubic meter. So now coming towards velocity, it is distance upon time. That means we need to write the distance SI unit. The distance SI unit is, again, we know that it is the meter. Like if I say I have traveled this much meter, so that is our meters. And then that if I talk about time, it is second, right? So if I say you here, okay, meter per second. Now, as you all know, acceleration is velocity by time, and we have already calculated the unit for velocity. It is meter per second, and time is already second. So first we'll write velocity. Now it is per time. So again time. That means again seconds. Right. Now coming towards force. Force is mass into acceleration, and we know that mass is what? Kilogram. And what is acceleration? Acceleration is meter per second per second. So in short, we can write it is Newton. It is Newton. And if I talk about pressure, it is Pascal. Right? So these were the units. Now for these units, we have to, students, write some symbols. Okay, for area, we write a symbol. Like for meter square, its unit is meter square. To represent it, we don't write such big names. We just use symbols to representation, right? For meter square, we will write meter square. For volume, it's cubic meter, then meter cube. Next is kg per cubic meter. Then we will write kg per cubic meter. That means meter power minus 3. Right. After that, students, that is our meter per second. The next one is velocity, which is meter per second. So we are going to write meter second power minus 1. Then comes our acceleration. Acceleration is meter per second per second. So we have to write it meter per second minus 2, right? Then next one which arises is force. Students, force is Newton, so we will write it with capital N, and Pascal we will write it with PA. So these were the symbols of these derived units which we have calculated, right? So these were all about derived units. Now come the prefix in SI unit. What happens, students, when we do some questions, we observe that there are some numbers which are seen in decimal, in fraction. For these numbers, we use some certain prefixes for the SI units. For example, in some cases you have seen that there is somewhere written millimeter, nanometer, decameter. So what are these? These are the prefixes that are used for decimal, fractions, all these cases, right? So the very first which you observe, which you have seen, for 10 raised to the power minus 24, we write it as y octo, and the symbol is used as y. For 10 raised to the power minus 21, we use prefix zepto, and the symbol is z. See, you have to just read it once. That's it. It is not like you have to cram it, okay? No, not at all. You just have to read it once, twice, thrice, that's it. And the ones that are most important, I will tell you to put a star mark on it, right? The next one is 10 raised to the power minus 18, which is atto, symbol is small a. Next is 10 raised to the power minus 15, which prefix is femto, and the symbol is small f. The next one is 10 raised to the power minus 12, whose prefix is pico, and the symbol is small p. The next one is 10 raised to the power minus 9, whose prefix is nano, and the symbol is small n, which is important. As I told you, I will tell you to mark this one. The next one is 10 raised to the power minus 6, which is known as micro, and the symbol is mu. Okay, this one is also important. The next one is 10 raised to the power minus 3, which is represented as milli, and its symbol is small m. While the next one is 10 raised to the power minus 2, and the prefix is centi, symbol is small c. The next one is, students, known as deci. Deci is 10 raised to the power minus 1, symbol is small d. So these are important, which I have been marking star for you, right? Now coming towards the next of the cases, we have only 10, whose prefix is deca, which is represented by dA. The next one is 10 raised to the power 2, which is hector, symbol is h. Then is 10 raised to the power 3, which is kilo, symbol is K. Then is 10 raised to the power 6, which is mega, which is capital M. Next is 10 raised to the power 9, which is giga, which is capital G. Next is 10 raised to the power 12, which is prefix is tetra, represented by capital T. The next one is 10 raised to the power 15, prefix is peta, represented by P. Next is 10 raised to the power 18, exa, represented by capital E. The next one is 10 raised to the power 21, which is zeta, represented by capital Z. And the next one is 10 raised to the power 24, which is zeta, represented by Y. So students, you don't have to learn it. I'm again saying just read it once, twice or thrice. That's it. And from NCERT, you can directly mark the star ones. That's it. Clear? So these were all about the derived units. Hence, we have covered the topic units. Now students, coming towards the uncertainty in measurement. What is measurement? We have studied how to, the properties of measurement and the measurement of physical properties. We have all covered this topic. Now coming towards the uncertainty. Uncertainty refers to as, if I say some number is 1.98, 1.96 in decimals or in fractions, that is uncertain. What is certain? Like a particular number, 1, 2, 3, 4, 5, 6, 7. So uncertainty is something that is something is wrong in this, there is some uncertain in that measurement. So here two terms which we need to understand is precision and accuracy, which we are going to explain you in a very funny manner. Now I will take you towards your childhood. Okay, how many of you students have played dark board game? What was that? Let me tell you. Let us draw it first. Okay, let us draw it first. It looked like this, It looked like this one. Let us make it and let us understand it in a very beautiful manner, students. Right? I guess you all have played it because I have played a lot. I will tell you the rules for this game. Now we will learn chemistry with ease in a very beautiful manner, right? Okay. Okay, now let us make it right. Okay, your goal is to put your stick or the object which you are throwing into the white portion. You have to do what? You have to take a stick which has a magnet in front of it, and this board also has a magnet in it. So what happens is when you throw it in such a situation, it arises just at the middle and you win the game. This is the basic rule of the game. And if it arises in, other regions of your game board, then you are not the winner. Okay, so what you need to do is you just need to throw your stick from a distance and it should arise like this. Tuck. Okay, clear? So there how do we calculate this? Let me tell you. Let us take one more here. Okay, the last one. 1 second, students. Okay. Yes, it is almost done. So I have made my game here for you people. So now let us learn it, how to play. Some basic rules here. If you put your stick into the yellow portion, you will get 5 marks. Okay. If you put your stick into the blue, you will get your 4 marks. If you put your stick into the pink portion, you will get 3 marks. If you put into the green one, you will get the 2 marks. And if you put into the first one, you will get the 1 marks. So this is the basic thing that you need to know in this game. You have to put your stick like this, do like this and tuck. Okay. Make an angle from the eye to put into the situation. Now, there are 2 students that are playing this game. Okay. So one is me and one is you, my students. I would write here. Okay. One is me and one is you. We both are playing this game now. Okay, during the class session. So what? We are taking this stick and we will put this stick 4 times and we will observe who is the winner. So I'm writing here case 1, case 2, case 3, case 4. Okay, students, let us see who wins the situation, right? Okay, now in this game, students, you have taken your stick into your hand and you are going to do a blast here. Let us see where you are going to put. You have put your stick into number 1. You have put your stick into number 1. Okay, now it's my turn, so as I'm not so good in this game, but I'll try my best to defeat you guys. See, so I have put my stick and I'm putting my stick is of red color, yours is of white color, right? I'm putting my stick into the 4th one. Okay, my stick is into the 4th one. Remember one thing, when your stick arises the first one, you are the winner. But there are 4 chances that we are getting and we will observe these chances, right? Now the case 2, again, you have taken your stick and what you are doing? You are again going to put it, right? When you are again going to put it, what you have done? It arises into the second most number. Okay. Second most number. Now again it is my turn. I am doing this again. I put into 4. See, I don't know how to play it because I have not practiced it. It's a long time I played in childhood, right? So again I have got 4th number because I put my slot into the 4th ring. Now it's your turn, students, again, and you are full determined to win the situation. You are in the victory batch and you have to achieve it, that. So what you are going to do, you again put it in the first box because this is your aim, students. If you are for NEET aspirant, JEE aspirant, board aspirant, you have to put your stick here, right? So you have put again the first one. Now it's my turn. So what I'm going to do is I am going to put again here because far at a distance I have not practiced. I'm like throwing like this, So again 4, no problem. My students wins, then I will win. Automatically I am the winner if you are the winner, right? Okay, the last case now. Again you have put your stick into the first situation. Well done, students. And again I have done here only in the 4th. No problem. Next time I will try to defeat you, right? So this was our game. Now who is the winner? Most probably, which we can see very clearly, the person who hits the centermost position is the winner, and you guys are the winner. You have hit your target very easily. So 1 1 1 1 you have seen, but in the second case you got 2. So what we have seen, this situation is known as accuracy. Accuracy. Coming towards chemistry, students, come back from the game. Your score is 1 2 1 1. That means you have to hit 1, and you have hit 1 thrice, but once it was twice. You are near to the answer. Near to the answer, close to the answer. And when someone is close to the answer, it is known as accuracy. Now coming towards me, who secured 4 4 4 4 during this hit. Now, I have been doing 4. I was not good at the point to target it. But see what I did. It was my consistency that I maintained it. 4, 4, 4, 4, 4. So this situation is known as precise. This situation is precision. Now, what is the situation? When there is a consistency for the same quantity. Like for same quantity refers to as 4 4 4 4 4. So there is a consistency that is referred to as precision. And when there is a closeness towards your target, that refers to as accuracy. Hopefully you loved this game a lot, right? So let us first read these definitions to make it more clearly understandable. First of all, precision I would talk about refers to the closures of various measurements for same quantity. Now you will say that, ma'am, for closures or for close, you have told the word accuracy when it is near to the answer, but you are using the word here closure. Here closure refers for the same quantity, 4 4 4 4 4, right? That means consistency. And if I talk about accuracy, it is the agreement of a particular value to the true value of the result. True value is 1 and it is the agreement that it is close to the true value. So that is accuracy. Clear? Now let us move towards a wonderful example of NCERT. There are 3 students A, B and C. And they have been doing a match. In that they got some measurements and they participated twice. So they got measurement 1 and measurement 2. And the correct answer, students, The correct answer was 2, right? Now let us check here which is accurate and which is precise, right? So the student first A, let us talk about student A. If I talk about student A, students, the first time measurement was 1.95, the next time measurement was 1.93. Now both the situations, are close by, but they are not close to the number. They are not close to the target too. Hence, they are consistent because the number is almost equal. You can say that, ma'am, you have got 44444, but they are not 1.939393. No, but at least they are close to the same quantity. Closer to the same quantity. That means they are precise. They are consistent. So this situation is precise. Are they accurate? When will be they accurate? They will be accurate when they are close to the target. But target is 2, hence they are not accurate. So accuracy is absent in this case. Right. If I talk about the second situation of the student B, there are two measurements again. The first measurement is 1.94 and 2.05. Now students, please observe firstly about accuracy. Accuracy is the one when we are close to the target. The target is 2. Is 1.94 and 2.05 close to 2? No. What is close to 2? Close to is like 2 is something like 1.99, 2.01. These are close to 2. Hence, they are not accurate. So, now let us talk about precision. Are they precise? No, because there is no consistency. This comes under the category of 1 something. This comes under the category of 2 something. So, here they are not precise at all. Now, if we'll talk about student C, what we observe here, 2.01 and 1.9. And yes, they are close to 2. Hence, they are accurate. So, tell us about precision. Are they precision? Yes, they are precision. I have told you that they comes under category of 1, 2, so they are not precise because they are not some of, consistency is not there of the same quantity. Here it is almost same quantity. 2.01, 1.99, they're almost nearby. Very nearby, and that means they have consistency, hence they are precise. So we have learned about accuracy and precision. This is very most important, which you need to understand and which you need to keep in your minds. Okay, so now moving towards the next, that is scientific notations. Students, scientific notations are the one that means when we represent a number in the form of 10 raised to the power something. For example, you have been given any number like 0.00978. You are given this number and I am saying that please represent this number in forms of 10 raised to the power something. When I represent this number in terms of 10 raised to power something, it is referred to as scientific notations. How? In 10 raised to power n. N can be 1, 2, 3, 4, 5, 6, 7, 8 like this, right? So see how to do this, how to convert it into such situations. There are certain rules which we need to understand. The very first rule, rule number 1. Rule number 1 states that if we shift towards the right from the decimal towards right from decimal, then students, power is negative. Power is negative. Example, please let us see. Example is 0.00978. You need to understand the two basic terms which I already, I want you to know so that it becomes easy for you. Okay, I am making a box here. In this you need to write non-zero digits. What are non-zero digits? Students, non-zero digits are the one that is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, which are other than 0, they are referred as non-zero digits. Now, you need to accomplish the rule 1, you need to understand what is non-zero digit, which I have told you. First, find out that whenever we shift towards the right from the decimal, then we need to find the first non-zero digit. Here, this 9 is a non-zero digit. 0 is a 0 digit, 0 is a 0 digit, 0 is a 0 digit, but 9 lies under the category of non-zero digit. So when you find the first non-zero digit, what you need to do is you need to move this decimal after this. You have to do this to make it bring under the category of scientific notation, that is 10 raised to the power something. So what you are going to do is you are moving in such a situation like 1 decimal place, 2 decimal place, 3 decimal place, and after this you want to get, na? So what you will do here? You will do here that After 9, you want point, decimal. You will put decimal. What comes next? 7, 8. Now you will write into 10 raised to the power what? You are moving in which direction? Towards right hand direction from the decimal. Then you have to write the power in negative form. And if the power is in negative form, then how can you count 1, 2, 3? After third position decimal is coming, power is in negative form. So 10 raised to the power minus 3. Clear? So now comes the next rule, students. That is our rule number 2. Okay, if I talk about, students, the rule number 2, I would say that if we shift towards left position from decimal, then power is positive. Example. Okay, I am taking one more example. It is 7,000. Okay. Now, any decimal is present? No decimal is present. That means we have to move in from the left position. We will move from the towards the left position. When there is decimal, then you have to move into the right position from the first non-zero digit. What is the first non-zero digit here? 7. So we need to put decimal after the first non-zero digit. Hence, after 7 we have to put. So we will move in this direction to put it after 7. How many zeros I have to cross? 1, 2, 3. That means 7 into 10 raised to the power what? 3. It should be positive because we are moving in which direction? We are moving, students, in our left direction. So this was all about scientific notations, and in NCERT also you will observe some basic things, for example addition, subtraction, multiplication and division. The very first thing that you need to remember in all those cases is that the basic rule. When you are given some numbers to add, for example 2.1, I am taking here 2.1 plus 4.22. What you will do this, you will add both of this number. When you are going to add these numbers, now students, you will get the answer is 6.32, right? You are getting this answer. This answer is incorrect. Why this is incorrect? Because you need to find out here what? You need to find out here that during the, during this question, it is the simplest. But when you get into the terms of scientific notations, this is the simplest case when you can directly add. But for example, these decimals are not given. You are given something in 10 raised to the power something in scientific notation. What you will do? For example, if I say 5.7 into 10 raised to the power 6. Okay, you need to add it into 4.2 into 10 raised to the power 6. What you will do? What you will do, students, when you are going to add both of these situations, you can directly add them. But when you are given a situation to multiply, what you are going to do? In multiply case, it is a quite different situation. In addition, subtraction, it is directly you are taking 10 raised to the power 6 common and then you will go to add them. This is the basic way of addition and subtraction which we do in mathematics. But if I put a symbol of multiplication here, what you will do? In multiplication, students, the powers are being added, while in division the powers are being subtracted. So when the powers are being added here, what is going to happen here? 5.7 into 4.2. As I told, powers are going to add. So 10 raised to the power 6 plus 10 raised to the power 6 can be written as 10 raised to the power 6 plus 6. Clear? Because powers are already being added. You can multiply this and the answer will be something into 10 raised to the power 12. But in the case of division, for example, I give you the same situation in the division case. How can you do so? Please see that also. It's very simple. You will get these all in mathematics also, but still I'm telling you so that you don't get confused. There are very less chances of the questions in these kinds of stuff. Just you need to know about these two rules, since I'm going to tell you so that it is more clear to you, right? So one more case, if I take, if I say it is like I'm taking 5.6 into 10 raised to the power 6 divided by 4.2 into 10 raised to the power 4. So what we will do in the case of divide, the powers are being subtracted like this. And then we are going to write 5.6 divided by 4.2 like this, students. So here powers are being subtracted, here powers are being added. Clear? It is very simple, students. Now students, let us see the very next topic. which we are going to study is significant figures. Significant figures is a very interesting topic and you will find it very easy. You know, there are some students who feel mathematics is tough, but let me tell you, this mathematics topic, significant figures in chemistry, is very, very easy and interesting. There are certain rules for significant figures, and these rules will help you to find out the value of significant figures in certain questions. So there are some rules. The very first rule is that all non-zero digits, what are the non-zero digits? From first towards the ninth one, 0 is not included in that, right? So all non-zero digits are significant. Now let us take an example. Before example, please underline this. Okay, it is very important rule. Take an example, 285 centimeter. Please let me tell you, is 2 a non-zero digit? Yes, ma'am. Is 8 a non-zero digit? Yes, ma'am. 5 is a non-zero digit? Yes, ma'am. So how many significant figures are present? 3 significant figures are present. You just need to find out the non-zero digits because all non-zero digits are significant. So how many significant figures here? Here are 3. Okay, one more example is 0.25. So how many significant figures are there? I have told you that only non-zero digits. 0.25 contains 0, which is 0 digits. So this will not be counted. Hence, 2 and 5 will only be counted. So there are 2 significant figures. Hopefully the first rule is clear to you. The second rule is zeros preceding to first non-zero digits are not significant. That means if there is any non-zero digit and the zeros are present before that, they won't be counted. Okay, so let us take an example. 0.03. So this is the first non-zero digit, 3 is the non-zero digit, and if a 0 arises before that, these zeros are not counted, hence it has only one significant figure. And coming towards the next case, 0.0052, these will not be counted because they are coming before the first non-zero digits, hence the answer is only 5 and 2 will be counted, so answer will be 2 significant figures. So kindly please put it into a box again because this rule is also very, very important for you people. Now coming towards the third rule, students, what is the third rule? I would say the third rule is very simplest. Zeros between two non-zero digits are significant. See, zeros before non-zero digit is not significant, but between two non-zero digits is significant. Let us take an example. This is non-zero digit, this is non-zero digit, and these are the zeros. So these will also be counted, and hence there are 4 significant figures in this case. So this rule is also most important. So kindly underline them. And now we are moving towards the last 2 rules of the significant figures. The last 2 rules state very easy. I have told you the value of 0 before the non-zero digit and in between the non-zero digit. Now we are talking about the 0 value after the non-zero digit and in the case of decimal. So let us see. Zeros at the end or right of the number are significant. Before and center seen, now the right one case or the end one seen case, the zeros are significant provided they are on the right side of the decimal, but they will only be counted when they are at the right side of the decimal. Now let us take this example. Will the 0 be counted? No, because it is before this decimal, so it won't be counted. This 2 is non-zero, yes, it is counted, and these 2 zeros are after decimal, so they will be counted. How many significant figures are there? There are total 3 significant figures here. Okay, but if otherwise the terminal zeros are not significant, there is no decimal point. So see, if there is no decimal point, for example, simply 200 is given to you. One situation is only 200. You will write, no decimal is there. You can write it as 10 raised to the power 2. We have already done in scientific notations, right? So these will not be counted and hence only one significant figure. But if it is given to you 200.0, then after non-zero digit, this is also counted. Hence, how many significant figures? 4. Clear? Okay, now let us take one more example. They have taken 100. 100 has only one significant figure. Why? Because we can write 100 in terms of 1 into 10 raised to the power 2. And this is not counted and hence only one significant figure is there. But students, if I talk about 100.0, then after decimal 1 will also be counted and hence they have 4 significant figures. The same thing which I have explained you is written here in both of the situations. They have taken 100 as an example, 1.0 into 10 raised to power 2 as an example, and 1.00 into 10 raised to power 2 as an example. Now coming towards the last rule, that is counting the numbers of object. For example, if I say 200 and if I say 200 balls. So if I say 200, it is referred to as what? It is referred to as this situation which I have explained you. But if I talk about 200 balls, I am talking about an object. And when I'm talking about an object, then it has no limit, and hence its significant figures are infinity. So in this case, you can see that if directly it is given to you 2 balls, 20 eggs, so the answer is infinite significant figures because they are exact numbers, and we can write these numbers in such way. So when there is an object, you need to remember this thing, students, that it has infinite significant figures. But if not mentioned, then you have to do in the same case. Okay, now let us apply these rules in the following questions. The very first question is in front of you. Okay. First thing, students, as you know, questions are there. Many of the students will skip this portion just for the sake that they are very uncomfortable to do questions. Let me tell you, whenever you face questions, you need to tell your mind and your heart that you can do this. You can do this. See, if you won't do this, no one else can do this. You know, you have to do this for yourself. And these questions will only lead you towards the good results. And for good results, you need to practice. So if first time, if you are unable to do so, don't lose hope. Just try again. Second time, again they are not coming the exact answers. No problem. Don't lose hope. Try once, twice, thrice, 4 times, 5 times, 6 times. I am assuring you the same, that after 10th or 15th or 20th or 40th time, you will be like, give me any question. I can do any question, because you have understood the concept very deeply by practicing. So please practice to achieve your success. More practice will lead you towards the success, right? So first of all, I will tell you how to look into the question, which approach you should apply towards a question, and then we are going to solve. We have seen 5 rules. We will consider the rules and we will solve the questions. Okay, with me you are going to do and you are going to achieve it. So see, the first question is 0.00325. Here you need to first approach towards this concept that you need to find the non-zero digit. What is the non-zero digit? Non-zero digit is the one in which 0 is absent. So here this is 0, this is 0, this is 0. Hence they won't be counted. This is the non-zero digit, this is the non-zero digit, this is the non-zero digit. So all non-zero digits are significant. And second rule was that before non-zero digit, zeros are not counted. So before the zeros are not counted, hence its answer is 3. Clear? Now comes the next case, students. See this case. In this case is 9.007. We have studied this rule. If 0 comes in between 2 non-zero digits, then they are counted. This is the first non-zero digit. This is the last non-zero digit, and hence these zeros will also be counted because they are coming in between. Hence, how many significant figures are present? 4. Right. Very good. Now coming towards the third question, as I told you, if object is mentioned to you, then you have to write infinity. If it is not mentioned, you have to directly do this. How many non-zero digits? 3. Answer is 3. Coming towards the next case, fourth case, 8.00. I told you the after first non-zero digits, if any decimal is there and 0 is approaching afterwards, then it will be counted. So these will be counted after decimal ones. Answer is 3. Now in this case also, answer will be 1, 2, 3 and 4, students. Now coming towards the next case, as I told you that 1 into 10 raised to the power 2. We have not considered 10 raised to the power 2. Hence again 10 raised to the power 6 will not be included. Answer will be 1, 2 and 3, students. Now coming towards the next case, you can say 989. Here will be 3 of the non-zero digits. Answer will be 3. The next question, all are non-zero digits. 1, 2, 3, 4, 5. Answer will be 5. So this was all about our significant figures questions. Now we are moving towards the round of portion. Round of portion is very simplest portion. You have already done this in small classes also. What is round of stands for? If you are getting some questions in a big decimal number, so you do round off to bring it into a small terms. For example, you have 0.22. You have 0.25. You have 0.35. You have 0.27. You have 0.28. Now what you need to learn is, whenever the last digit is more than 5, then the number before that will get a number and the last digit will disappear. How? See, in this case 8 is more than 5, the last digit, so it will give its one number to this and will disappear and will do round off. So what is the answer? 0.3, because 8 is more than 5. Now take this example, 0.27. 7 is a big number, more than 5. It will give its number to 2, it will be 0.3. Clear? Now coming towards the case when the last digit itself is 5, what you will do? In that case, students, when the last digit is 5 but before that there is an odd number, here is 3, hence it will be getting one number from it. So it will be 0.4. But if there is an even number before 5, it will not get any point and the answer will be 0.2, because I told you round off only occurs when the number is more than 5. That's why. Okay, the last case here is 0.22. Students, in this case, the last digit is less than 5. Hence, it will remain same and the answer will be 0.2. So this was all about round off situation. Students, you will be observing some of the questions in addition, subtraction, multiplication, division. But in the round of case, you just need to find out the decimal places. In addition and subtraction, if you are given some questions, just see how many decimal places are present and the answer will contain the same decimal places as of the shortest number. But in the case of multiplication and subtraction, you have to see the significant figures rule. This is not so important, just you need to know about the round off. I just give you a brief about that situations. Now we will move forward towards the laws. So let us start the laws position and you can note it down and you can practice more questions on this concept. Law of chemical combination. Students, there are various laws of chemical combination. One of them are law of conservation of mass, the second one is law of constant proportion, students, the next one is law of reciprocal proportion, the next one is law of multiple proportion, and the last one which we will study will be Gay-Lussac's law of volume. Okay, so now let us start from the very first law, that is the law of conservation of mass. Students, law of conservation of mass teaches us that mass can neither be created nor be destroyed in any chemical reaction. What we observe here is that total mass of reactant is equals to the total mass of product. So this is the main important point that we need to remember during the law of conservation of mass, that it states us that mass can neither be created nor be destroyed in any reaction. So the most important point, that total mass of reactants is equal to the total mass of product. It is very simple, students. Okay, the total mass of products. Right? Kindly put this into a box so that you remember for your further questions. Now, let us apply this formula into our very first question of the law of conservation of mass. What mass of silver nitrate will react with 5.85 grams of sodium chloride to produce 14.35 grams of silver chloride and 8.5 grams of sodium nitrate? If the law of conservation of mass is true. So we need to prove it, if it's true or not. Okay, if it's true, then we have to follow this and we need to find what? We need to find the mass of silver nitrate, right? Okay, first of all, I'm going to write the given situations which is given to me, the given substances and their masses, right? So it's given that silver nitrate, it means AgNO3. It will react with 5.85 grams of sodium chloride. What is sodium chloride? It is NaCl. To produce, now it is producing something, that is product is being formed. Okay, then we are going to apply an arrow. Now, what is being produced? Silver chloride. That means silver chloride is our AgCl. And 8.5 grams of sodium nitrate. Sodium is Na and nitrate will be NaNO3. So, students, first of all, write this as like this. These are our reactants which react together to form products, right? You all know these things? Good. Now, students, we have been given that we need to find the mass of silver nitrate. So let us say that its mass is X grams, because everything is taken in grams. So we assume that the mass of silver nitrate is X grams. It is reacting with NaCl, whose mass is given to us 5.85 grams. So it is 5.85 grams, right? Then it is producing us AgCl, which is about 14.35 grams, right? 14.35 grams. Moreover, it is producing NaNO3, which is 8.5 grams. So now, as you all know, according to law of conservation of mass, according to law of conservation of mass, mass can neither be created nor be destroyed. Hence, what do we say that? We say total mass of reactant is equal to total mass of product. Clear, students? So, what will be the general formula? General formula will be AgNO3 mass plus NaCl mass will be equal to the product's mass, AgCl plus NaNO3. Hence, we can write that X grams plus 5.85 grams is equal to 14.35 grams plus 8.5 grams. Okay. Now, this is X plus 5.85 grams is equals to, we are going to add these. It is going to be, students, okay, right. It is going to be 15.15 grams. Let me check this. 14.35 grams plus 8.5 grams, right? Okay. Okay. Now we are going to take this on the another side, right? One second. Kindly correct this. Yes. Just to solve this in a better situation, what you can do is, if you are getting this at a 1 decimal place, put a 0 aside here so that it will be easy for you to calculate. Now 5 will come here, and this is 8, and 8 and 4 is 12, and 1 is carried forward, so it is 22.85. Clear? Okay. Now we are going to this on this side, and our X value will come out. So X will come out to be 22.85 minus 5.85, which is about 17 grams, students. So our answer is 17 grams. Okay, clear. Simplest thing that we need to remember in the law of conservation of mass is total mass of reactant should be equal to total mass of product. Clear? Very good. Now proceeding towards our next law, that is the law of constant composition. Basically, law of constant composition defines us that when two elements combine with each other, they combine in a simple fixed whole number ratio. Okay, now just take an example. If I want water, okay, I am taking a water from at a mountain hills. I am taking water from river. I am taking water from lakes. I am taking water from pond. The water I am taking from different region is still composed of fixed ratio. Water is made up of like two ratio of the like oxygen. There are two parts of hydrogen combining with one parts of oxygen. That means if I say what is the ratio of water, water ratio will be 2:16. That means 1:8. So if I go on a mountain or if I go on a river or if I go in a lakeside to get water, the ratio will be still the same at any places. So this is what? This is the law of constant proportion, that when the two elements are what? Hydrogen and oxygen. When they combine with each other, then the fixed mass or the fixed weight is observed. They combine in a fixed ratio of weight or fixed ratio of masses, right? So we can write that it states us that the elements combine in a fixed ratio by weight. Clear? Okay, students. Now coming towards our next law, that is the law of multiple proportions. Okay, we are going to do the next law, that is law of multiple proportions. The best way to deal with laws is students kindly understand the concept. Like in this law, what we are observing about the two elements concept, that two elements are combining with each other and they are present in the fixed, ratio. So whenever you see the questions and there are the three compounds given to you, kindly consider that those three compounds contain the same kind of elements, so that you can identify that this is the kind of law of constant composition, because there will be the same elements, then only there will be the fixed ratio of these elements, right? So when you come across the law of multiple proportion, kindly consider this, that there will be at least three elements in this situation, three different elements in this situation. So in the case of law of multiple proportion, what we say that when two elements combine with the fixed, the fixed mass of the other element, they are present in fixed ratio with each other. Okay, to understand this in a very better form, I would take an example of law of multiple proportion. If I say that of carbon dioxide and carbon monoxide, I'm taking two examples. It's like carbon dioxide and carbon monoxide. So what I'm observing is this, when two elements combine with the fixed mass of other elements, like in carbon oxygen, here one element, like if I'm taking of carbon is in one part, oxygen is in one part, while if I take in this, carbon is in one part while oxygen has two parts. So in this case, carbon monoxide, CO, we observe that the ratio of carbon to oxygen is going to be 12:16, while if I take of CO2, what I observe is the ratio is going to be 12:32. Why 32? Because one oxygen has a mass of 16 and two oxygen will have a mass of 32. So what I observe is one element has a fixed mass. The fixed mass, one element has the fixed mass, while the other elements will be present in fixed ratio with each other. Hence, the oxygen's ratio will be 16:32. O ratio O2 will be 16:32, which is 1:2. So it is a fixed ratio. What I'm trying to convey to you, that whenever you are looking to the law of multiple proportion, you will see that there will be elements like in both of these elements, one element will have a fixed mass, and that will be combining with the other element, and that other element will have the fixed ratio with the compound of the other element. Like in this oxygen will have fixed ratio with this O2, which is going to be 1:2. So this is the example of law of multiple proportion. Now let us take an example over this. 2.16 grams of copper metal when treated with nitric acid followed by ignition of the nitrate gave 2.70 gram of copper oxide. In another experiment, 1.15 gram of copper oxide upon reduction with hydrogen gave 0.92 grams of copper. Show that the above data illustrate the law of definite proportions. So students, now only we have started the law of constant proportion, which are also known as law of definite proportions or definite composition. So don't get confused what is law of definite proportions. It is still the same. Now what we are going to do is, as I have already told you, in this case what it tells us that there will be always a fixed ratio by weight. So we are going to find that only. Now taking the example 2.16 gram of copper metal. 2.16 gram of copper metal. You know, it is treated with nitric acid followed by ignition of the nitrate, which is producing 2.70 gram of copper oxide. Like 2.16 gram of CO is producing 2.70 gram of copper oxide. Clear? In another experiment, what is going to happen, students? In another experiment, 1.15 grams of copper oxide upon reduction with hydrogen gave 0.92 grams of copper. Kindly consider this. In the next one, in the next situation experiment, what we are seeing that this much copper oxide on reduction with hydrogen is giving us this much copper. So we need to show that this data is following the law of definite proportion. How can we explain them? We will find the percentage of copper and oxygen in copper oxide. So first of all, I will find the percentage of Cu in copper oxide. So what I'm going to do, the mass of Cu which is given to me divided by the total mass of the substance, that is the copper oxide, into 100. So it is 2.16 divided by 2.70 into, it is going to be 100. In this way, students, we are going to calculate such situation, and we are going to get 80% here, right? When you are going to solve this, it is about 80%. So what we have found that Cu percentage in copper oxide in the experiment 1. I am talking about experiment 1. In experiment 1, it is 80%. So the leftover percentage is of oxygen, right? So percentage of oxygen in copper oxide in experiment 1, it is going to be 20%, right? Now let us see the next case, the experiment 2 case. If I talk about experiment 2, students, in experiment 2, what it is given is 0.92 grams of copper is produced. From how much copper oxide? From 1.15 grams of copper oxide. So again, I'm going to find here the percentage of copper as well as of oxygen. So if I found the percentage of copper, what I need to do is I need to write the mass of copper upon the mass, total mass, into 100. Same 0.92 divided by 1.15 into, we'll do 100, because we need to find the percentage, students. So when we calculate it, students, it is about 80%. Okay, it is about 80%. So the leftover is oxygen. Hence, we can say that percentage of oxygen is 20% in experiment 2. So now tell me, as I already told you in the previous case, that water in any area, in any aspect, will have the same, the same fixed ratio of their masses, of their weight. Wherever you go, wherever, their elements will be in fixed ratio. So you can see in both of these experiments, they have fixed ratio, 80:20, 80:20, right? So they have fixed ratio, whatever may be the situation is. So yes, it illustrates the law law of definite proportions. Clear? Good. Now students, coming towards our next question, two oxidation metals contains 27.6% and 30% of oxygen respectively. If formula of the first oxidation is M3O4, find the formula for the second one. So it is very simply, it is given us that there are two situations in which metal is being reacted with the oxygen and it is forming metal oxides. There are two experiments, but for the first one we have been given the formula, but for the second one the formula is not given. So how can we calculate this? First of all, write the experiment 1 or the situation 1. In the experiment 1, what we observe is the formula is given us, which is M3O4, right? M3O4, and we have already been given the percentages of oxygen in both the cases. Like in the first case, they are saying 27.6% of oxygen is present. In the first one, in first case, percentage of oxygen is 27.6%. Now students, please just tell me that M3O4 and the percentage of oxygen is 27.4. We can say that how many oxygen atoms are present here? 4 oxygen atoms are present there. But before that, tell me the percentage of metal here. How can you calculate? Look, whenever such questions arises, always consider that the total percentage is 100. Hence, if oxygen is present 27.6%, what will be the metal? 100 minus 27.6%. It is going to be 72.4%, my dear students. It is going to be 72.4%. Now we have calculated the percentage in the first case where we have been given the formula, right? Now what we are going to do? We are going to write the second case, right? In the second case, in the second experiment, what information I've got? I don't have the formula, but I know that percentage of oxygen is 30%, right? So the percentage of oxygen in the second case is 30%. So the other portion obviously will be the metal, right? So I would say that percentage of metal would be 100 minus 30, hence it will be 70%. Now in both these cases we have already calculated the percentages. Now what will be the other next step? In the next step we will observe that here 4 parts of oxygen, have percentage 27.6. Right. So how much I would say oxygen will be present for the next case? We need to calculate it. It is little bit of mathematics you can consider, but don't get confused. By step I am going to explain you. First of all, I am going to explain you about the metal M. See, 3 parts, these are 3 parts of metal gives 72.4% of metal, right? You know this thing. Now if I say 1 part of metal will give how much? 1 part of metal will give you how much? This you need to carry. This you need to calculate. So, in other words, we need to calculate this. But it has already told us that the percentage of metal is 70% in the another case. So, we have been given 70% is already present. We don't know how many parts of this metal will be formed. We don't know this situation. We just only know that 3 parts are giving us 72.4%. So how many parts will be formed when 70% is there? In short, reverse the situation to do this question. It will be easy for you. I would say 72% is present in 3 parts. So in 70%, how many parts will be present? It will be 3 by 72.4 into 70. Like this, you can do the question. First of all, write the situation, understand the situation, what they are going to tell you. So whenever you will solve this, students, it will be approximately 2.90 something. It will be approximately this much. Now, what is this? These are the parts of metal that arises. Here are 3 parts. Now, you have already found how many parts are there? How many parts are there of metal? 2.90 parts of metal in case 2. Similarly, we are going to calculate for the oxygen part. Now see, again I am telling you here the percentage is given 27.6%. 27.6% gives 4 parts. So how many will 30% give? Same thing arises. I am saying 27.6% gives us 4 parts, right? Now, I am telling you 70% will give 4 by 27.6 into 70, my dear students. It will be about 4.35. 4.35 parts of oxygen. Okay, now we have already calculated the parts of oxygen as well as the parts of metal. Now, as you know, we do the ratio forms, so we are going to write it here. Metal ratio oxygen for the second case. Now, firstly, you need to write for the metal. For the metal, we have calculated 2.90. For oxygen, we have calculated 4.35. My dear students, it is going to be near about 1 ratio. I would say 1.5 approx. 1 ratio 1.5. So in short, whenever we get it in decimals, we try to convert it into a fixed number so that it is easy for us. So to convert 1.5 into a number, I would say just multiply it with 2. That would be easy for you. So if you multiply with 2, it will be 2 ratio 3 students. Hence, what will be the formula? M base 2 oxygen base 3. So the formula that is obtained for the second part is M2O3. It is clear to you. It is very simplest question, but the students get confused in this question, like in this part of the question. So you need to understand first right situation in such a way and find out what you need to calculate. You need to calculate the parts. So kindly convert this in this form. It is a simple basic mathematics so that it will be easy for you to calculate the formula and formulate it. Right? So through this question we can elaborate and calculate different questions. Now moving forward towards the next law, that is the law of reciprocal proportions. Students, law of reciprocal proportions states between the 3 elements. Like if I say there is carbon, there is hydrogen, there is oxygen. What happens is carbon forms bond with hydrogen and forms a compound which is CH4. Then I see a case where carbon forms bond with oxygen and the compound that is formed is CO2. In the next case, students, hydrogen oxygen also combines with each other forming water. So what is the law of reciprocal proportion? It states us that when 2 elements, consider any 2 elements, for example, I am considering carbon and oxygen, when these 2 elements combine with the fixed mass of the third element, means hydrogen. So first see what I am speaking. I am saying when carbon combines with hydrogen, it forms CH4. What will be their ratio, students, in CH4? It will be 12:4, right? Now, when oxygen combines with hydrogen, students, oxygen combines with hydrogens forming water, what will be their ratio? 16:2, right? We need to make one of the elements ratio constant. So I am making constant the ratio of hydrogen because I am considering these two formulas. You can consider any of the formulas by taking one as a constant fixed ratio. I am taking hydrogen's fixed ratio. So in this case, hydrogen is 4 parts. In this case, hydrogen is 2 parts. So what I'm going to do is I'm going to multiply this with 2. Now what I'm getting is oxygen ratio hydrogen. That means when it is multiplied with 2, it is 32:4, students. Clear? Now the new ratio is 12:4 for CH4, and for water, after multiplying it with 2, we are getting 32:4. What happens is the ratio of hydrogen is now fixed. So what we are observing? We are observing that if the ratio of hydrogen is fixed, then carbon oxygen ratio will be 12:32. Clear, students? It is simplest. Or I could say if I divide it on the table of 2, I would say 6:16, right? It is 6:16. If I divide on the table of 2, or if I further divide it on 2, it will come out to be 3:8. Clear? Simplest? Okay. Now students, I have found that after fixing the ratio of hydrogen, the ratio of carbon and oxygen is 3:8. Now, individually, what will be the ratio? Let us calculate that. Individually, if I consider both of these cases, when carbon directly combines with oxygen, when carbon directly combines with oxygen, students, what we get? What is the ratio we get? 12:16. Now I will again divide it on the table of 2. What I am getting? 6 ratio. I am getting 8. What I am getting here is 6:8. But please do remember, the compound here formed is carbon dioxide, not carbon monoxide. So here it will be 16 into 2, hence 2 into 8, or I would say again, if I cut it on the table of 3, it is 3:8. On the table of 2, sorry, it will be 3:8. Here the formula is CO2, not CO. So you have to remember in your minds the formulas. First formula is CH4. Accordingly, you will write the ratio. Second formula is water. Accordingly, you will write the ratio. Third formula is CO2. Accordingly, you will write the ratio. So what is the thing that is we are observing here? We are observing that when we are considering the two elements and keeping the ratio of the third element fixed, we are getting both of these ratios 3:8, which is equal to the situation when they both combine directly. Hence, this is law of reciprocal proportions. Hopefully, it is clear to you. Now, moving forward towards our question. Hydrogen combines with chlorine to form HCl. Clear? I'm going to write the situation. It will be easy for you, right? Hydrogen, what it does? It combines with chlorine, right? To form HCl. Okay. The next one is sodium combines with hydrogen again to form NaH. Okay, now it says if sodium and chlorine also combine with each other, sodium and chlorine also combine with each other, students, they will do so in the ratio of their masses. We need to calculate the ratio of their masses. Now, we have already done this situation. See, we have already calculated the situation. See, hydrogen, chlorine, and I would say sodium. When hydrogen combines with chlorine, it is forming HCl. When chlorine combines with sodium, it is forming NaCl. When hydrogen combines with Na, it is forming NaH. So, look into the situation like we did previously. First of all, in the case of HCl, the ratio will be 1:35.5. We are always taking the masses their weight, right? In the case of NaH, again, sodium ratio hydrogen, Na is 23 while hydrogen is 1. So what we are observing here, the hydrogen mass is already what? It is already fixed, right? If it is already fixed, my dear students, so what we observe in this situation, that Na and Cl will have what? Na and Cl will have 23:35.5. Clear? Because hydrogen masses are now constant in both of the cases. So the leftover is these both, and these are 23:35.5. If we did individually also, then also it will be coming out 23:35.5. Now, you will say that, ma'am, in these options, A and B are almost similar. How to identify? Please look at the formula. The formula is NaH. So first of all, you have to write the ratio, the mass of Na, then hydrogen. Na is 23, then, NaH and NaCl and HCl. It is like this now, and it is being asking about NaCl. So first of all, we'll write about Na, then we'll write about Cl. So Na is 23, then is 35.5. So which option will be correct? A option will be correct. Answer will be option number A. Clear? Okay. Now proceeding towards the next questions, my dear students. Which of the following combination illustrate the law of reciprocal proportion? We have already understood in the law of reciprocal proportion, we at least need three elements that is being contact with each other, right? So in the first case only nitrogen and oxygen, in the second also compound nitrogen oxygen, in third also. So this is not possible at all because we need at least three elements different. In second B option, again phosphorus hydrogen, phosphorus oxygen, phosphorus sulfur. See, likewise, I gave you the previous case. What we did was hydrogen, chlorine and Na. They three had connection with each other. But here what you see, phosphorus, hydrogen, oxygen, sulfur. It is not possible. It is not possible. Four elements, no. So it is not considered. Now the C option, carbon is present, sulfur is present, oxygen is present. Carbon is forming bond with sulfur, which is CS2. Carbon is bonding with oxygen, forming CO2, and sulfur is forming bond with oxygen as SO2. So you can directly see that it follows the law of reciprocal proportion. Hence the answer C will be our correct one. Clear? Very good, students. Now we are proceeding towards the last law, that is the Gay-Lussac's law of combining volumes. What does it states us? It states us that according to this law, when the gases, please consider this, when gases reacted together, they always do so in the volume which bear a simple ratio. A simple ratio to one another and to the volume of products. For example, if I say H2 reacts with Cl2 to form HCl. Students, first of all, balance it out. Here are two elements of hydrogen. Here are two elements of chlorine. Here are only one elements of hydrogen and chlorine. So what you will do is, you will put a twice number here so that it is balanced out, right? So what we say that here it is 1, 1. Right? So if I say that, if here it is one part, I would say if it is gaseous, so here one volume of H2 reacts with one volume of H2 to Cl2 to give 2 volume of HCl. How I can say that? On the basis of this stoichiometry, on the basis of these numbers which are present in front of them. Like one H2 is combining with one Cl2 to give 2 HCl. That means one volume of H2 is combining with one volume of Cl2 to give 2 volume of HCl. So in which ratio are they? They are in 1:2. They bear a simple fixed ratio. So this is the law. According to this law, when gases react with each other, they do so in volumes, right, which bear a simple ratio to one another. To one another they bear a simple ratio, but also to the volume of product. If these are also gases, provided all the measurement of the volumes are done under similar conditions of temperature and pressure. They are done under the similar conditions of temperature and pressure. So this was all about the Gay-Lussac's law. You need to just put the stoichiometry correct. That's it. If you will able to do this balancing out, then you can find this ratio very simply. First balance out, then you can find the ratio. It is as simple as it is. Right, students? And now comes the question part. Just look at the question. If law of conservation of mass was to hold true. Now, what was law of conservation of mass? When total mass of reactant is equals to the total mass of product. This was the law of conservation of mass. Then 20.8 grams of BaCl2. BaCl2. How many? 20.8 grams. Reaction with 9.8 grams of H2SO4 will produce 7.3 grams of HCl. Let us write it down. Okay, it is given 7.3 grams of HCl and BaSO4 equals to. We need to find out the mass of BaSO4. So it is as simple. What was the formula of law of conservation of mass? Total mass of reactant is equal to total mass of product. Students, now the total mass of reactant will be 20.8 plus 9.8 is equals to 7.3 plus X, right? First of all, we'll add them. It is 30.6, students. It is going to be 30.6. Let me just do this again. Yeah. So is equals to 7.3 plus X. Now this will come here and subtract. 30.6 minus 7.3 is equals to X, which is going to be 3. So it is going to be 23.3 grams, my dear students. Now let us see the options. Hence B option is our correct one. Clear? So the law of conservation of mass states us that total mass of reactant is equals to total mass of product. So here students comes the Dalton atomic theory after the laws. Dalton atomic theory states us about atom. Basically, Dalton atomic theory tells us that matter comprises of very small, extremely small, indivisible particles that cannot be divided, students, which are known as atoms. And these atoms, students, of a given element are identical in all aspects. In which aspects they are identical? That they have same size, they have same shape, they have same mass, they have same chemical properties. The next thing is that atoms of different elements are different in all respects. See, atoms of same element will have all the same properties, but atoms of different elements will exhibit different properties. For example, they possesses different shapes, sizes, mass in all of these, right? Then it comes that atoms of different elements may combine with each other. They can combine with each other in fixed, simple or whole number ratio to form compounds. Clear? They can form compounds. Next thing is atoms can neither be created nor be destroyed in a chemical reaction. Students, but there were the limitations of Dalton atomic theory which couldn't explain us about isotopes. You know, the second thing was that they weren't able to explain about how they were able to form compounds, how different elements could combine and form compounds. So these were the limitations of Dalton atomic theory, right? So now we are proceeding towards our next topic, that is going to be atomic and molecular mass. But before atomic and molecular mass, we need to understand about atom, which we have already done in Dalton atomic theory. That atom is the smallest indivisible particle and it is responsible for any chemical reaction, right? But what we see is that when we go into market, what is the need, of mole concept, of bringing this chapter to you? The main reason is that there are many quantities which we can measure, but there are some quantities which we cannot measure. To measure them, we have introduced mole concept. How I am saying that? If I go to market to buy some fruits or bananas, I say that I need 1 dozen bananas. 1 dozen stands for 12 bananas, right? And then the next day I go and I ask for 5 dozen. So how many bananas I'm going to get? 60 bananas I'm going to get. So what I've done for bananas, I have set an equation. I've set a standard like dozens, right? So I can calculate that in terms of fruits and vegetables. But when I come across chemistry, there are some quantities, there are some atoms whose amount of substance is not being calculated in terms of dozens or kgs or like this, no? So we need to introduce a term, and hence we introduced atom. So these atomic mass helped us to calculate the amount of substance in chemistry field, in chemical reactions. So whenever we could correlate this with the daily life situation, for daily life we have referred a standard. Similarly, for chemical reactions we have kept a standard, that is C12, carbon, as our standard reference. With the help of that, we are going to calculate all the masses. Like with the help of carbon atom, we can calculate other atoms' element masses, and through them we can calculate atomic mass and molecular mass. So what is going to be the atomic mass, students? Atomic mass of an element is number of times an atom of that element is heavier than an atom of carbon taken as 12. Why we are considering here carbon here? Because as in the case of vegetables, we took dozen as a reference. In the case of chemistry, we took carbon as our reference. That's why. Then the definition which is important to you is this one, that one atomic mass unit, which is known as AMU, it is equal to 1/12th of the mass of an atom of carbon-12 isotope. Clear, students? So now we are going to start mole concept in detail, considering each and every situation when volume is given to us, when molecular mass is given to us. So now let us start towards the mole concept. So yes, students, as you all know, we are doing mole concept, and mole concept, first we need to understand what is a mole. Basically, a mole of a substance is 6.022 into 10 raised to the power 23 particles, which is referred to as Avogadro's number. So I would define first of all mole for you. What is mole? Mole is defined as Mole is basically defined as 1 mole of a substance is equal to 6.022 into 10 raised to the power 23 particles. Now students, I am talking about particles. Here particles are of various kinds. It can be electrons, it can be protons, it can be neutrons, it can be atoms, it can be ions, it can be elements. Everything lies in these, particles can be any of them. So in short, I can say that 1 mole is equals to 6.022 into 10 raised to the power 23 particles. Here you can add molecules also instead of elements. Okay. So 1 mole is equals to 6.022 into 10 raised to the power 23 particles. Particles I've already told you, these can be these things. And this value, students, is known as Avogadro number. Okay. Now, what is the use of this Avogadro number? We will use this in formulas and it is going to be very interesting and very easy topic. Okay, so now let us proceed towards our next fundamental particles, which I already told you about: electron, protons and neutrons. Now, the particle electron has mass 9.1 into 10 raised to the power minus 31 kg and its charge is minus 1.6 into 10 raised to the power minus 19. As it is electron, so negative charge comes in front of this. Then protons come, which are positively charged particles. Proton basically is represented by small p and its mass is 1.67 into 10 raised to the power minus 27 kg and its charge is 1.6 into 10 raised to the power minus 19. While if I talk about neutron, then the mass is 1.67 into 10 raised to the power minus 27 kg and its charge is neutral. So these are the fundamental particles which we should know. Right. Okay. Now, one of the question that they can ask you is calculate charge on 1 mole of electron. Basically, students, to calculate charge on 1 mole of electron, we need to calculate it by number of electrons into charge on 1 electron. See, we have to calculate charge of 1 mole of electron, right? And for that, the formula is number of electron. Total number of electron into charge of only single electron will help you to calculate the charge on 1 mole. As you all know, 1 mole is basically 1 mole contains how many electrons? We have just done right now. 1 mole contains this kinds of particles. Particles can be electron. That means 1 mole have this much of electrons, right? So now here, how many electrons are present? 6.022 into 10 raised to the power 23, which is Avogadro number and it is represented by Na. Clear? Into, now comes the charge on 1 electron. We have just done right now, charge is 1.6 into 10 raised to power minus 19. You don't have to put this negative sign when you are calculating something. It is just to represent that electrons are negatively charged. So now we will put the same value, 1.6 into 10 raised to the power minus 19. Right? So when we will solve it, it will come 96500 coulomb. It comes in coulomb. You can convert it into Faraday also, which is equals to 1 Faraday. So by this way, we can calculate the charge on 1 mole of electron. For example, they ask you on 2 mole of electron, then you can multiply it further. So these kinds of questions can be asked on fundamental particles. It is the basic thing that you can get to know. Right. Now students, I am coming across the most important and interesting part of the chapter, which is atomic mass. Basically, what is atomic mass? Atomic mass is the mass of 1 moles of atom. And there are certain atomic mass that you need to learn. For example, the atomic mass that you need to be learned, you have to learn it in grams. Basically, gram atomic mass is referred to as when we represent mass in terms of grams. When atomic mass of an atom is represented in grams, it is known as gram atomic mass. For example, hydrogen has gram atomic mass 1. This you need to learn the table which I have drawn here. Other than this, only 1, 2, 3, 4 would be there that you could recall and learn, right? But these are important for you to learn to calculate molecular mass. Okay, hydrogen has gram atomic mass 1, helium has gram atomic mass 4, lithium has gram atomic mass 7, beryllium has gram atomic mass 9. Then we have further boron, which is gram atomic mass 11. Then we have carbon as 12, nitrogen as 14, oxygen as 16, fluorine as 19, neon as 20, sodium as 23, magnesium as 24, aluminium as 27, and they can also ask you about chlorine, which is about 35.5. Okay, this is a little bit different, so they can ask you the same also. So you need to learn these elements and their gram atomic mass. Practice will make you perfect when you will apply them on questions, right? Great. Students, now you need to calculate the atomicity or molecularity. What do you mean by atomicity or molecularity? It tells us how many atoms are present in a molecule. So, for the first case, it is given that C12H22O11. How many atoms are present in this case? See, how many carbon are there? 12. How many hydrogen are there? 22. How many oxygen are there? 11. So, we'll add them. It is 45. That means 45 atoms are present in this case. Now taking this case, how many potassium are there? 2. How many sulfur? 1. How many oxygen? 4. How many aluminium? 2. How many sulfur? It is into 3. Plus how many oxygen? It is 4 into 3, that is 12. How many hydrogen? Again 24 into 2. It is going to be 48. Plus how many oxygen? It is 24. So students, by this way, when you calculate it, it is about 3 plus 4, 7, 7 plus 9, 9 plus 3, 15. It is going to be about 96, right? Clear? So, basically, it tells us about the number of atoms present in a molecule, right? So, we need to calculate all those elements, the number of elements, right? Now, students, the next thing that comes is the molecular mass. Molecular mass is the mass of one molecule. How do we need to calculate it? For this, you need to learn the table which I already told you. You need to individually learn the elements gram atomic mass so that you can apply here and you can solve it. Now, let us see for the case of CH4. How many carbons are there? 1. So, 1 into carbon's mass plus how many hydrogen is there? 4. 4 into hydrogen mass. By this way, you can calculate. What was the mass of carbon in the table? It was 12. You can go back and check. So, 1 into 12 plus what was for hydrogen? 4 into 1. So, it comes out to be 16. So, 16 is the molecular mass. Now, coming towards CO2. Again, how many carbon are there? 1. So, carbon into 1. That means mass of carbon into 1 because 1 carbon atom is there. 2 oxygen atoms are there. 2 into oxygen atoms mass. So, carbon atoms mass is 12. 12 into 1 plus oxygen mass is 16. 16 into 2. So, it comes out to be, students, 44. These table, if you have learned, then only you can calculate the molecular masses. Otherwise, it will be quite difficult for you. Now, coming towards KMNO4. Now, if I talk about KMNO4, students, then we need to write the masses for potassium as well as Mn, right? So, the mass for the mass for potassium is 1 into potassium's mass plus 1 into Mn's mass, then plus 4 into oxygen's mass, right? Potassium mass is 39, right? So, 39 plus, now comes for Mn mass, it is about 55, then comes for oxygen, that is 4 into 16. So, it is 39 plus 55 plus 64, which comes out to be 94 plus 54, it is near about 158, students. Clear? Now, if I talk about C2H5OH, how many carbons are there? 2. 2 into carbon's mass plus how many hydrogens? 6 into hydrogen's mass plus 1 into oxygen mass. Carbon mass is 12. So, 2 into 12 plus 6 into 1 plus 1 into 16. If we solve it out, 24 plus 6 plus 16. How much, students? It is 46. Clear? Now, okay, coming towards a C4H10. So, more practice will make you more clear. So, first of all, learn the gram atomic mass individually for the atoms, then apply it here. It will be coming in seconds. Clear? C4H10. How many carbon are there? 4. 4 into carbon's mass plus 1 into hydrogen's number, right? 1 is the mass of hydrogen. So, if we solve it, it is 48 plus 10, that is 58. Now comes the last part, that is urea here. Okay. Nitrogen mass is 14 and here are 2 nitrogens. So 14 into 2 plus. There are total 4 hydrogens and its mass is 1. So directly I'm writing 4. Carbon is 1, so I'm writing 12, and oxygen is 1, so I'm writing 16. So it comes out to be 60. So it is the molecular mass for urea. Clear? So by this way you can calculate the molecular masses. Now students, coming towards the formula for the mole concept, that is very important. There are 3 basic formulas that you need to apply. Number 1 is number of moles are represented by small n. It is number of moles which is equal to given mass upon molecular mass. The very first formula. Molecular mass you have calculated just right now. Given mass will be given to you in question, right? This is the first formula. The very next formula which is important for you is number of moles in terms of volumes will be 20. It will be volume of substance. It will be volume of substance divided by 22.4. So this is in the case of when you have given the volume. You can apply directly this formula. And the very last formula that you use for number of moles for the case of molecules or atoms. So number of molecules or atoms divided by Avogadro's number, which is 6.022 into 10 raised to the power 23. So these are the 3 basic formulas that you are going to apply for the questions in the case of mole concept. If you have to find the number of moles, you can directly use these formulas according to the given situation. If you are given mass, then you can calculate this. If you want to calculate the volume, you are given number of moles, you can use this formula. If you want to calculate number of moles and you are given number of molecules, you can use this formula. Now students, one question is there. Calculate mass of 2.5 mole of Cl2. Now number of moles here it is given 2.5 moles, right? And we have to calculate the mass of Cl2. That means given mass of Cl2 is missing. So we can calculate molecular mass. We have just learned that Cl2. I have told you how many Cl? 2 into Cl's mass. Cl mass is 35.5. Right? So if I solve it, it is 71 students. Now, after this, number of moles formula is number of moles is equals to given mass upon molecular mass. Now, number of moles is 2.5. Given mass we need to calculate and molecular mass is students is 71. Now, when we cross multiply it, it comes out to be 177.5. Clear? So let me calculate it in detail so that it is easy. Let us check first, I guess. 5, 2. Yes, it is the same. 177.5. Clear? Okay. Now it will come grams because we are taking it in grams, right? Okay students, now let us see the flow chart. Flow chart here is to represent the 3 basic formulas. How 3 basic formulas can be correlated with each other. See, if you are given mass and you are asked to calculate number of molecules, you can directly use this formula to calculate. How I have used this formula? Okay, I'll tell you about this slide. See, number of moles is equal to given mass upon molecular mass. Also, number of moles is equal to number of molecules divided by Avogadro number. So, if left hand side is equal, we can put the right hand side equal. So, this is the correlationship of these formulas which we can apply. Another with the volume also you can do the same. Given mass upon molecular mass is equals to volume of substance by 22.4. Right students? So this you can use as a correlation of the 3 basic formulas of mole concept. Now students, next comes our question which has the maximum number of atoms. Now let us see that. The first case is 24 grams of carbon. In the case of 24 grams of carbon, how many number of atoms are present? Now, see, what is the formula of number of moles? Number of moles is given mass upon molecular mass, and also number of moles is equals to number of molecules or number of atoms divided by Avogadro number, that is 6.022 into 10 raised to the power 23. So here given mass is 24, molecular mass of carbon is 12, is equals to, we need to calculate number of atoms. Do not write students Avogadro number in the full form like 6.022 into, it will be very complex. So just write it as Na because we need to compare it, right? So when we divide it, it is 2, it is 2Na. So for the first case, number of atoms that came out is 2Na. Now for the next case, now for this case, it is given mass is 56, molecular mass is also 56, into Na will be equal to number of atoms, hence it comes out to be 1 Na, right? Okay. Now the third is aluminium. 27 grams of aluminium. Given mass is 27 and aluminium mass is also 27, right? And when we'll cross multiply according to this formula into Na, it will give us number of atoms. Hence, students, it's come out to be 1 Na. And the very last one, we have 108 grams of Ag. Again, given mass is 108, molecular mass is 108 into, we will do Na, right, to get number of atoms. So it again comes out to be 1 Na. So students, what we have done here is we need to find the maximum number of atoms, and we have found the maximum number of atoms in the case A, which is 2 Na. Clear? Now we'll proceed towards our next topic. So yes, my dear students, now we are going to start reactions in solution. We are going to see the concentration terms. So the very first term is mass percent. Mass percent or mass percentage, or in other terms, we defined it as weight by weight percent. How do we calculate it? According to the name mass percent, that means there is a relationship between mass, right? So the definition for mass percent, or I would say weight by weight percent, is that mass of a component that we need to calculate is present in total mass of the solution. It defines us that how much mass of the component is actually present in the total mass of the solution. So if I define its formula, what would be the formula of weight by weight percent? It is refers to add mass of component divided by mass of solution into 100. If I speak in terms of solute and solvent, what do you mean by solute and solvent? Students, solute refers to the substance which is present in less amount, and the solvent is the one which is present in the more amount. Solute and solvent comprises to form solution. So if I speak in that terms, I would define mass percent or weight percent as mass of solute divided by mass of solution into 100. Why do we multiply this into 100? Because we are calculating this in the terms of percentage. That's why. So now let us see one question. A solution is prepared by adding 4 grams of a substance A to 16 grams of water. Calculate the mass percentage of solute. It is very simplest question, students. Here we need to calculate the mass percentage of solute. As I told you, the mass of solute is always present in less, and the solvent is more. Like the one that is being dissolved is solute, and into which it is being dissolved is solvent. For example, let me explain you in detail. This is my beaker. It contains solvent. Now, the thing that I am adding from above is known as solute. So when solute is being added into solvent, it refers to as solution. It consists of solution. They are asking us to calculate the mass percentage of the solute that is being added. That means they are asking about the mass percentage of the substance A that is being added into the solution. So what is the formula? Its formula is mass percent or weight by weight percent is equals to mass of component, which is the component A, 4 grams mass, divided by mass of solution. Now solution comprises of both solute and solvent. That means 4 grams of substance A plus 16 grams of water will make a solution into 100. So it is 4 by 20 into 100. Now 4 5s is 20, 5 20s is 100. Hence answer is 20%. That means the mass of the solute is 20%. It was an easy question. It was an easy formula. So now students, we are considering one more example here. See, a solution contains 20 grams of glucose in 100 grams of water. Calculate mass percentage of glucose as well as water. Now see, we need to calculate the mass percentages of both the components of glucose as well as of water. So the first formula will work here, like the component whose mass you have to calculate divided by total mass into 100. So it is as simple as that. First of all, you need to write the mass percentage of glucose. To calculate the mass percentage of glucose, you need to calculate the mass of glucose upon total mass of the solution, total mass of the solution, and into 100. This will calculate for glucose. Now, if I ask about mass percentage of water, what will be the formula? It will be mass of water divided by total mass of solution, students, into 100. Now, the component whosoever you want to calculate should be kept on the above on the numerator, and on the denominator always you have to put the total mass of solution. Please remember that you have to put of solution, not of the particular solvent. Sometimes students only write what is given in the question. They forget that solution is consisting of solute as well as solvent, right? So now if I put into these situations here, mass of glucose is given 20 grams and solution mass is going to be the addition of both of them. That is 20 plus 100 into 100. So when we solve it, it is 20 by 120 into 100, right? I'm cutting the zeros. Then 2 6 are 12. Here I'm getting 100 by 6, which is going to be 16.67% something. It is 16.67%. So the percentage mass of glucose is 16.67%. Now I'm going to calculate the mass of water. So the mass percentage of water is mass of water divided by total mass into 100, students. So the mass of water, what it is? 100 grams given in the question. Right, students? It is already given to us in question, divided by total mass of the solution. Solution consists of solute as well as solvent, so we need to add both of them. That is 20 plus 100 into 100. So here what I get? 100 upon 120 into 100. Again, one zero is cancelled with the other zero. Now if I cut it on the table of 2, it is 500 by 6, students. So I'm getting it at 83.33% something. Right? So this was all about the mass percentage question. Now students, we are moving towards the next concentration term that is referred to as mole fraction. It is the most simplest concentration term, I would say. Mole fraction. What do you mean by mole fraction? First of all, understand this. What is moles? Moles refers to as given mass upon molecular mass, right? Okay. Now, to define mole fraction in detail and to discuss about moles in detail, students, first of all, you need to understand about mole fraction. Mole fraction is represented by zeta. It is equals to number of moles of substance A divided by number of moles of substance A plus number of moles of substance B. That means total substance moles into 100. Right? So students, I am considering that there are two beakers. or it is divided into like half of the category. So one contains A particles, another contains B particles. Now if I have to calculate how much is A particles present in that beaker, I need to calculate number of moles. To calculate number of moles for the particular component, you have to keep the number of moles of that component on the above position, and it should be divided by total number of moles. So hence, if I have to calculate the mole fraction of A, I will keep number of moles of A above divided by total number of moles into 100, right? Now, moving towards the mole fraction of B. What will be the formula? Number of moles of B divided by total number of moles into 100. Now, I have already written this formula also in case in some of the questions what happens is they don't give you directly moles. They give you given mass as well as molecular mass. So, first of all, you need to calculate number of moles with the given formula, given mass upon molecular mass, and then you need to apply it into the following formulas. That's it, students. So, students, now let us see an example for this. If 30 grams of acetic acid is mixed with 46 grams of ethanol, then find mole fraction of both the compounds. Now, for A as well as for B, that means for acetic acid as well as for ethanol, we need to calculate the mole fraction. So, first of all, acetic acid is CH3COOH, right? And ethanol formula is C2H5OH. No need to worry that, ma'am, we don't know the formula. No need to worry. In organic chemistry, when you'll come across the chapters, you will learn these concepts also. What is the formula? How is the composition? You'll get to know in that terms. First of all, I'm already telling you because you are new to these terms, right? So, acetic acid is CH3COH while ethanol is C2H5OH. Now, we need to calculate their mole fractions. So, we need to calculate the molecular mass. Why I am saying we need to calculate molecular mass? Because students, here, number of moles are not given to us directly. So, first we need to calculate number of moles for the particular components. And for that, given mass is already given in the question. Now, we will calculate the molecular mass, students. Right? To calculate the molecular mass, what we are going to do, see, how many carbons are there? 2 carbons. So 2 into carbon's mass, that is carbon mass is 12. Plus how many hydrogen? 4. 4 into hydrogen mass. Hydrogen has 1, right? Plus 2 oxygen atoms into 1 mass of oxygen atom is 16. So what will be the molecular mass? 24 plus 4 plus 32. That is going to be 28 plus 32. That means it is 60 grams. This is the molecular mass for acetic acid. Now, let us calculate its number of moles. Number of moles for acetic acid is given mass upon molecular mass. What is the given mass in the following question? 30 grams. Divided by molecular mass is 60. So, I am getting number of moles as 1 by 2, right? Now, moving towards the ethanol portion, first of all, we need to calculate the molecular mass. What will be the molecular mass for this? How many carbons? 2. The mass for one carbon atom is 12. So, we'll multiply it with 12 plus how many hydrogens? 6. 1 is the mass of hydrogen plus 1 into oxygen's mass, that is 16. So, it is going to be 24 plus 6 plus 16, that is going to be 46, students. So, this is the molecular mass for ethanol. Now, we will calculate number of moles for ethanol. Ethanol has molecular formula C2H5OH. So, I am writing is like this. Given mass upon molecular mass gives us number of moles. What is the given mass given in the question? 46. What is the molecular mass we have calculated? 46. So, how many moles? 1 moles. Now, to calculate mole fraction, we have already calculated number of moles. We will apply our basic formula. What is the basic formula? Number of moles of A component divided by total number of moles is equal to number of moles for the A component. Let us say this is the A component and this one is the B component, right? So, okay. First of all, number of moles of A component is half divided by total moles, that is going to be half plus 1. So, it is going to 1 by 2 divided by 3 by 2. Hence, it is coming out to be 1 by 3. So, the mole fraction I would say for CH3COH is going to be 1 by 3. Now, to calculate for ethanol, we have to do same. Mole fraction is going to be number of moles of B divided by total number of moles. What are the number of moles of B? They are 1 divided by what are the total? It's 3 by 2, as 1 by 2 plus 1 by 2 plus 1 is 3 by 2. So I've directly written that 3 by 2. So 2 will go upwards, it will be 2 by 3. Hence mole fraction for ethanol is 2 by 3 and for acetic acid is 1 by 3. So this is the formula how we can calculate mole fraction. Right, students? Now we are moving towards our next concentration term, that is known as ppm. It is very simplest. What is ppm? It is the concentration of component. Basically, the component whose concentration we need to calculate present in 10 raised to the power 6 parts of solution. First of all, write the full form of this. Parts per million. As you can know, here it is written parts per million. That's why we have taken 10 raised to the power 6 here. So what is going to be the formula for ppm to calculate ppm? The formula is mass of solute divided by mass of solution. Mass of solution, students, into 10 raised to the power 6. Now let us one second, solution will come here, kindly correct that. Just think that when we were doing mass percentage, what we were doing? Mass of solute divided by mass of solution into 100. But now we are taking mass of solute divided by mass of solution into 10 raised to the power 6. What is the basic difference between both of these? Here we are talking about parts per million. That's why we are multiplying it with 10 raised to the power 6. This is the basic difference. That's all, students. So this formula is being applied to calculate the percentage ppm, that is parts per million %. So now we'll move forward towards our next concentration term, that is molarity. And students, you all will be thinking that, ma'am, so many formulas, how will we will learn these formulas? So trust me, these formulas can only be learnt by your own practice. Practice, determination and consistency. These three things will lead you towards success. And if you will follow these three things, then you can achieve anything. See, for the very first day when you start doing these questions and when you listen to our lectures, some of the students will grasp it quickly, while some of the students will feel like it is taking time for us. No need to worry at all. Just three things you need to do is, you need to increase your day-to-day time schedule. If you are working for 1 hour, you are studying for 1 hour, increase it to 1.5 hours. Then increase it to 2 hours. Then on the next day, increase it to 2.5 hours. Like this, you will be able to sit and do your work and do practice, and the consistency will increase and maintain. So this is the basic thing. Don't start in a rush that I have to do complete in a day. I have to do complete syllabus in a day. No. Take small steps and then you will achieve to your success. Right? As you know, if there are two students, there is two ways to achieve to success. One is stairs, another one is escalator, or I would say lift, I would say. So the stairs won't stop you to achieve to success. You can go through stairs, but it will take time. It will take time. Small, little steps. But what if lift falls or lift stops in between towards moving from ground towards the height? What happens? What you will do? You can't do anything. So always the method which is hard, try to do that. No problem that it is taking time. There is no problem. You have time and you can do. So do and you will achieve success, right? So small efforts leading towards molarity. What is molarity? Molarity is the simplest concentration terms, which defines as that number of moles of solute present in 100 volume of solution, 100 liters of solution. Clear, students? So students, molarity is symbolized by capital M, right? We symbolize molarity by capital M. What is molarity? Basically, molarity is number of moles of solute present in 1 liter of solution. So what will be the formula of molarity? Molarity is number of moles of solute present in 1 liter of solution. That means we have to take volume of solution below and it should be in liters, right? If you are taking volume of solution in milliliters, the formula will be modified as molarity is equals to number of moles of solute divided by volume of solution in milliliter, hence it will be divided by 1000 if you are taking in milliliter terms. One thing more students, the twist that comes in the questions is that they don't give you directly number of moles, they will give you given mass. So you have to replace number of moles by given mass upon molecular mass. They can give you direct, but in some cases they don't give you number of moles, they give you given mass. Molecular mass you need to calculate and put it into the formula. So this was all about molarity. Students, in molarity, one of the questions is in front of you. Find molarity of 40 grams NaOH dissolved in 250 ml solution. So listen, what is given mass here? 40 grams. As I told you, they will not give you number of moles directly. So given mass is 40 grams. Okay, now NaOH, what will be the molecular mass? Molecular mass for NaOH. How many sodium? 1 sodium. Mass is 23. Oxygen mass is 16. Hydrogen mass is 1. Hence, the molecular mass is 40 grams. So, now we need to calculate molarity. What is the formula of molarity? Molarity is number of moles. What is number of moles? Given mass upon molecular mass. Given mass is 40. Molecular mass is 40. Divided by volume of solution in milliliters now. When we take in milliliters, we divide it by 1000. So, 250 divided by 1000. 40 is cut by 40 and then it is again cut. Hence, we get 4 molar, students. We are getting 4 molar, right? Okay. Now, students, what we need to do is we have to do molarity of dilution. What do you... सर कट कर देना यहाँ पे, आप टाइम नोट कर लो, मैं उनको बता दूंगी एक बारी. टाइम है 3:05 पे, ठीक है? कहाँ से होगा ये? ओके, कंटिन्यू. Let us continue now. Now we are going to do molarity of dilution. Students, dilution means to add something, right? If I am having 1 beaker, what I am doing, I am having 2 beakers, right? I have 2 beakers. Now, in this beaker, students, this is my volume V1. It has volume V2. And this has number of moles as N and this has number of moles as N. What happens is, initially I had this beaker, I just added some amount into this and so it converted into volume V2. But number of moles remained same. Why number of moles remained same? Because number of moles is dependent upon given mass and molecular mass. That's why. And we are adding something. And number of moles, you know what is molarity's formula? Molarity formula is number of moles of solute divided by volume of solution. And when we are adding liquid, then volume is being increased, not number of moles. Number of moles of solute remains the same because we are taking here solute moles, not solution moles. If we used to take solution moles, then it would had increase. But we are taking of solute. So, N stays remain in both of the cases while volume changes from V1 towards the V2. Now what happens is, students, when N is same for both of the cases, what we say? N is equals to MV. Now what we can say, if N is equals to MV, then we can write N is equals to M1 V1 and N is equals to M2 V2. Now both of the terms will be equal. Hence the formula obtained is M1 V1 is equals to M2 V2. This is the formula for molarity in dilution, molarity of dilution. That means, for example, you are given a question, as you can see on the screen, how many volume of 10 molar HCl solution should be dilute to water to prepare 2 liter of 5 molar HCl. Now, Let us see with the help of diagrams to make it more understandable. I have these two beakers. In the very first beaker, they are saying how many volume of 10 molar HCl. I have molarity here 10 molar, right? Should be dilute to water. Should be dilute. What should we add into it? To prepare, what we need to prepare, what we are preparing, students? You need to check this, what we are preparing. One second. Yes, I am adding something into this and it converts into this. And to prepare 2 liter of, now it is becoming 2 liter and 5 molar HCl. Now, what I have got? I have got this volume V2. I have got this molarity M2. And in the start, I have molarity M1 while I don't have V1, right? So, first of all, I will calculate V1, right? See. So, M1 V1 is equals to M2 V2. M1 I know is 10. V1 I don't know is equals to M2 is 5 and V2 is 2. V1 is equals to 5 into 2 by 10. Hence, V1 is 1 liters. That means the first beaker had 1 liter volume. But the question is incomplete now. They are asking us how many volume of 10 molar HCl should be dilute. It should be dilute. How much should be added so that it becomes 2 liter? What should be added in 1 liter so that it becomes 2 liter? Obviously, 1 liter will be added into 1. So, how many volume will be added? 1 liter volume will be added. But if it asks you in question, what is the volume of beaker first or before dilution, then you would say 1 liter. And when it asks you how much dilution is required, then you will subtract your V2, right? V1 from V2 and you will get your answer. Right, students? Okay. Now comes molarity of mixture. Molarity of mixture refers to as when one beaker is mixed into the another beaker and we are getting a mixture. For example, I have this beaker, I have this beaker, then students, I have this beaker, right? See, I am adding these two and I'm getting this product, right? This is my beaker A, this is my beaker B, and this is my solution, which I am getting after the addition of both of them. Here in A, molarity was M1, volume was V1. Here, molarity was M2 and volume was V2. Here, molarity will be M. M refers to as the total molarity of the solution, while volume will be V1 plus V2, right? So, what will be the formula to calculate the solution's molarity? The complete formula will be M1 V1 plus M2 V2. Now, to calculate molarity of the solution that is capital M is equals to M1 V1 plus M2 V2 divided by total volume, that is V1 plus V2. Hence, this is the formula that is used to calculate the molarity of mixtures. Clear, students? Very good. Now, students, we are moving towards the relationship between molarity and molality. What is the relationship between molality and molarity? Before that, let us understand the basic difference between molality. Molality is that concentration term in which we don't use volume, students. In molarity, what we used to do? We used to define molarity as number of moles of solute divided by volume of solution in liters. This was molarity. But when I talk about molality, what do you mean by molality? Molality is number of moles of solute present in mass of solvent in kg. Now, one more difference which you will observe is in molarity we were taking volume of solution, but in molality we are taking mass of solvent and in kg. So formula will be molality is represented by small m. It is number of moles of solute divided by mass of solvent in kilograms. So this is the basic formula that you need to remember. Now, the relationship between molality and molarity. What is that? This is the relationship that you need to know. Molality is equals to molarity divided by D refers to as density minus molarity into molecular mass divided by 1000. This is the direct formula that you can apply in the questions when there is a relationship, when you are being asked about molality and you have been given molarity. So you can directly equate and get your answers. Clear, students? So this was the most interesting concentration terms, as there is a relationship. Try to solve as many questions as you can so that the relationship formula stays in your mind, right? Okay. Now, students, comes the next concentration term, that is referred to as normality. To understand normality, first we need to understand what is equivalent mass. What is equivalent mass, students? Equivalent mass basically is molecular weight by valency factor. Equivalent mass is equals to molecular mass or molecular weight basically divided by valency factor. Valency factor, or X, you can represent it. So, students, now, what is valency factor? See, for acids, if I talk about acids, bases and salt, first we need to calculate valency factor. For acids, we always go for basicity. For base, we always go for acidity. Ma'am, what are you saying? What is acidity? What is basicity? How do we identify it? So students, first of all, you need to understand the basic formula that is going to help you to calculate normality. First, you will calculate equivalent mass. How to calculate equivalent mass? Molecular weight by valency factor. Then, students, valency factor for acids, the formula will be changed. Formula for acids will be equivalent mass is equals to molecular weight by basicity. What is basicity? Basicity is the number of H positive ions that are liberated. For example, students, now let us take an example to understand the situation. You can take H2SO4, I guess, and other than this, you can take any of the acids, right? And for base, students, first let us write all the formulas, then I'm going to take some of the examples, right? For acids, for base, the formula is going to be equivalent mass is equals to molecular weight by acidity. Students, acidity refers to as how much OH negative ions are being liberated. For example, in NaOH, how many OH ions are liberated? 1, right? So basis, its acidity will be 1. You will write 1 here, and for the following question you will write the molecular weight and you will calculate the equivalent mass. But if I talk about salt, students, in the case of salt, what happens is equivalent mass is equal to molecular weight divided by what? Now you have to see the charge. You have to see either the charge of cation or the charge of anion, any one of these, right? Cation or anion. For example, MgSO4. In MgSO4, divide it will split into Mg plus 2 and SO4 2 negative. So you either take the charge of the positive or the negative. It's 2. So its valency factor, that is the charge of cation anion, will be 2. Don't put the charges positive, negative. That won't be put it. Only you have to put the number, that is 2. So valency factor in this case will be 2. Now for basicity, as I've given you example of NaOH, how many OH ions are liberated? Only 1. Then its acidity will be 1. Similarly, for acids, you can go for like basicity. Basicity refers to as how many H positive ions electrons are liberated. That will tell you it's about basicity. So this was all about valency factor, which will lead you towards the equivalent weights. And when you have already calculated equivalent weight, we will move towards the formula of normality, students. Now students, number of gram equivalent. We have to calculate number of gram equivalent. What is this? Number of gram equivalent. We have calculated equivalent mass, equivalent weight. So first of all, we will write given mass divided by the one that we calculated before, that is equivalent weight. And you know what is the formula of equivalent weight? Molecular weight divided by valency factor. So first you will calculate this, then you will calculate number of gram equivalent. And now we will calculate our normality, students. What is the formula for normality? Number of gram equivalent. Number of gram equivalent. This one. Number of gram equivalent divided by volume of solution in liters. In liters. And if they ask in milliliters, then you need to divide it by 1000. So students, it was about normality. And whensoever they ask you relationship between normality and molarity, what is the basic formula? Normality is equals to molarity into its atomicity. That means valency factor, which we calculate for acid, bases and salt. So this is the relationship between normality and molarity. Clear? We have done two relationships between molality and molarity. Now we have done between normality and molarity. Clear, students? Very good. Now students, the next thing that comes is the relationship between molarity and normality. I've already explained you in the previous slide. I'll proceed towards the next topic, that is percentage composition. Now percentage composition is required for empirical and molecular formula. First of all, we need to calculate, we have been given empirical formula, then we will calculate its molecular formula. So before understanding into these terms, the basic terms that will help us to calculate that is the percentage composition. Now let us start this. So yes, my dear students, now we are doing percentage composition. Basically, percentage composition is going to help us in empirical and molecular formula. What is percentage composition? For any component, we defined it as mass of that component divided by total mass of the solution into 100. So the percentage composition of any component is equal to the mass of component whosoever we need to find out the percentage that will be written on the above divided by mass of the compound, full compound, into 100. Now let us take an example for this, students. We have the example, calculate percentage composition of carbon in CH4. So it is very simple. First of all, percentage of carbon in CH4 will be mass of carbon divided by total mass of compound. What is the compound here? CH4 into 100. So now students, what is the mass of carbon? It's 12. What is the total mass? CH4 molecular mass? It is 12 plus 4, right? Into 100. Hence, it will come out to be 12 divided by 16 into 100. This is the percentage composition for carbon in CH4. Students, we can further divide it, like if we go on to table, then it is divided further. It is 75%. That means carbon is present 75% in CH4. And once they ask you about one component, they can even ask you about the another one. For example, hydrogen. So hydrogen you can calculate in the similar way, like you did in the carbon way. First, you will keep the mass of component of hydrogen divided by total mass into 100. Now, this is going to help us in empirical and molecular formula. What do you mean by empirical and molecular formula? See, whenever a compound we observe has two two formulas. The empirical formula represents the smallest whole number ratio. Smallest whole number ratio. This is the most important line that you need to remember. Whenever you see a compound can be represented in two categories, empirical as well as molecular formula. So in empirical, we need to see the smallest whole number ratio. For example, this is our compound. What will be the smallest whole number ratio? That the number through which they can be divisible. Like 6, 12 and 6, they can be divisible on 6 table. So if I divide this, then it will be C1H2O1. That means CH2O. CH2O is the simplest whole number ratio. That means for this compound, this is its empirical formula. Clear? Now, what do you mean by molecular formula? Molecular formula represents the actual number of individual atom in any molecule. For example, in C6H12O6, what is the actual number of carbon? 6. What is the actual number of hydrogen? 12. What is the actual number of oxygen? 6. So, molecular formula represents actual number of the each individual atom, while its simplest whole number ratio represents its empirical formula. Now, students, what is the relationship between empirical formula and molecular formula? So, I would say N is equals to molecular formula divided by empirical formula. So this is one of the relationship. What we can say it, molecular formula we can take molecular weight instead of this, and in empirical formula we can take empirical weight instead of this, because we need to calculate weight here for both of these. Right? Okay. Now I'm taking an example for you people where we are going to use this formula. The question is, a compound is molecular weight 90, right? Its empirical formula is CHO2. Find the molecular formula. Now students, we have been given empirical formula. We have been given empirical formula. Empirical formula is CHO2. What will its empirical weight? Empirical weight. How many carbon? 1. So 1 into carbon's mass plus 1 into hydrogen mass plus 2 into oxygen mass. Carbon mass is 12, hydrogen mass is 1 and oxygen mass is 16. So when I calculate it, it's 12 plus 1 plus 32. That means 13 plus 32, it means 45. 45 is the empirical weight, right? We have calculated empirical weight from empirical formula, but we need to calculate molecular formula. We have molecular weight with us. We have molecular weight which is 90 with us. Now I have given you a formula which is N is equals to molecular weight 90 divided by empirical formula or empirical weight, that is 45. What comes out to be N? N comes out to be 2. So what we will do now? We have our empirical formula which is CHO2. So I will multiply, I am going to multiply this with 2 so that I can get my molecular formula. Because I told you in the previous case, same this question. There are two kinds of formulas. One is molecular formula divided by empirical formula. The other one is molecular weight divided by empirical weight. We have used both of the formulas. First we used the weight one, then we used the molecular formula one. So what will it comes out to be? It comes out to be C2H2O4. So this is going to be the molecular formula. Like this, you need to put it into the down at the base, not on the top. You have to write it C2H2O4. Because here also in the previous case I told you now, what is the number that divides it into simplest whole number ratio? Right? So we are dividing it, that is N, right? So here this is the complete number of atoms. It represents the complete number of atoms while it represents the simplest whole number ratio. So this is empirical formula, this is our molecular formula. So you can calculate these kinds of questions in such a way. Now students, proceeding towards the next kind of question, what you need to do is, most of the times these questions are observed. A compound contains 38.8% carbon, 16% hydrogen and 45.2% nitrogen. The formula of the compound would be, first of all, you need to write element. First of all, you will write about element. How many elements are present in this? Carbon, hydrogen, nitrogen. The next thing, students, what you need to write down is, the next thing you will write the percentage composition, or you can write atomic mass first. So I'm going to write atomic mass first of these compounds. What is the atomic mass of carbon? 12. What is the atomic mass of hydrogen? 1. What is the atomic mass of nitrogen? It's 14, right? Now, the next thing that we are going to write is the percentage composition that is given to you in the question. Percentage composition. Now, what is the percentage composition for the case of carbon? It is given as 38.8%. What is the percentage composition for hydrogen? It is given to as 16%. What is the percentage composition of nitrogen? It is given to as 45.2%. Students, now the next step is going to be that we need to find the stoichiometry. That is, we need to divide percentage composition by atomic mass. So, what will come? Let us see. We will divide percentage composition by atomic mass. So, in the case of carbon, it will be 38.8 divided by 12. For the case of hydrogen, it will be 16 by 1. Now, for next case, it will be 45.2 divided by 40. Now, students, when we are going to solve it out, it comes out to be 3.23 something. It comes out to be 16, students. Then here it comes out to be almost 3.2322 something only. Right? So we have just calculated these. Now we have to put into the simplest form, students. How to put them into simplest form? Let us divide it in such a way that we get the answers. Like the first one we have done 3.23. Then we have done 16. Then is 3.23. What is the number that divides all of these? The number that divides all of these here, it would come out to be 1, 5 and 1. Right? Okay. So if you multiply 5 with this, you will approximately get, let me tell you the complete solution so that you won't be able to find any problem in this. See, it is 16.15. So it is approximately 16. That's why we always take at the approximate situation, because it's the percentage composition. So this is our simplest ratio. This refers to as the simplest ratio. What does we do? When we get this situation, we divide the smallest number with everyone. We are dividing 3.2 with 3.23. We get 1. We divided 16 by 3.23. We get 5. We are dividing 3.23 divided by again 3.23. So we are getting 1. The smallest number is being divided by all of them. So this is the simplest thing that we observe here. Now what we have to do? Carbon base 1. Hydrogen base 5. Nitrogen base 1. Now let us see the examples, the options here. In all of these options, they have opened it up. So we also need to open it up. How many carbon? 1 carbon. In this case, 1 carbon is there. In this case, 2 carbons are present. So B option is incorrect. In this also, it is incorrect. In this case, 1 carbon is there. Next, 1 nitrogen and 5 hydrogen. Now, 1 nitrogen and 5 hydrogen. It is possible. Okay, here it is 2 to 4 hydrogen and 2 nitrogen. It is not possible. Hence our A option, that is CH3NH2, is totally correct, students. So these kinds of questions can arise. First of all, you need to write the atomic mass. Then you need to write the percentage composition which is given in the question. Then you need to divide them. And after that, you need to select the smallest one and divide them so that you can get the simplest number. Now the simplest number is put into the base and the formula is obtained. So students, now we are moving towards the stoichiometry. What do you mean by the stoichiometry? Basically, stoichiometry deals with the calculation of masses of reactants as well as products in the chemical reaction. Whosoever mass we want to calculate, whosoever volume we want to calculate, with the help of stoichiometry, we can do this. They establishes basically 3 kinds of relationships. The first one is mass-mass relationship. For example, when 2 reactants react together and they form product. So in the question, what they'll do? They give you the mass of reactants and they will will ask you the mass of product. So that comes under the category of mass-mass relationship. When they give you mass-volume relationship, what do you mean by that? One of the reactant will be given mass, one of the reactant will be given as volume, and they will ask you about the mass of the product. So these kinds of relationships are mass and volume relationship. The last kind is volume-volume relationship, when the reactants volumes are given and the product volume is being asked. So students, one of the stoichiometric questions is in front of you. How to do, I will tell you. If 16 grams of methane is burnt, find the mass of CO2 produced. So see, methane is burnt. When it is burnt, right? So when methane is burnt, what happens is CO2 here is produced, right? So what we observe here is, what we need to find out the mass of CO2 produced here, we need to find out the situation, and also water will be produced here, right? Now the very first thing, the very first step that you need to do is balance the equation. How to balance the equation? Write reactant this side, write product this side. How many atoms are present at the reactant? First of all, we take off carbon atom. Carbon in the reactant side is 1. In the product side, it is also 1. Okay. The next one is hydrogen. In the reactant side, it is 4. In the product side, it is 2. Next is oxygen. In the reactant side, it is 2, while in the product side, it is 3. So we need to balance it out. That means we need to equalize it in both the ways. Now students, first of all, we can multiply this product side hydrogen into 2 so that it is equal to 4. So what I'm going to do, I'm writing 2 here so that it is multiplied. Now after putting 2 here, hydrogen is 4 but oxygen is also 2. That means on the product side we have 2 plus 2, 4 oxygen. We have now 4 oxygen with us, right? Now students, but on the reactant side 2 oxygen are present. That means we need to multiply here with 2. So here it is 4. Now check all the elements that they are equal in both the sides, in reactant and product, then yes, it is equalized. Why did I this? Because stoichiometry is the most important role we need to understand to calculate mass-mass relationship, mass-volume relationship, volume-volume relationship, right? Now students, look here. Here it is 1. When nothing is given, we consider it as 1. Here it is 1. It means 1 mole. It means 2 mole. It means 1 mole. It means 2 mole. Now, what do you mean by this? These stoichiometry are the relationships that are being established, students. These stoichiometric basically are the relationships. Kindly correct this here. Now, hydrogen is also 4. Right? These are equalized here. These are also 4. Even oxygens are also 4 on both the sides. Hence, we have done this, right? 2 plus 2, 4, 2 plus 2, 4. Now, how to calculate the mass of CO2 produced? See students, what happens is, they have given us the mass of methane, CH4. And we need to calculate the mass of this. So, I would say 1 mole gives 1 mole of CO2. I can say that 1 CH4, 1 mole of CH4, 1 mole of CH4 gives 1 mole of CO2, right? So, their moles are equal. And what are moles? Given mass by molecular mass. Here it is equal to given mass by molecular mass of CO2. What is the given mass here of methane? 16. What is the molecular mass of methane? CH4. It is 16 again. It is equals to given mass that we need to calculate divided by molecular mass of what? CO2. Its molecular mass is 44. Right. So if we'll solve it and cross multiply, we get the given mass as 44 grams. Hence we can calculate. But most of the students can ask, why not we are considering this O2? 2 mole gives 1 mole, because they have only given us one situation. When 2 situations are given, then we consider about limiting reagent. When 2 of the reactants information is being provided, then we first find out what is the limiting reagent, and then we do. Then if only one equation is given to us, then we directly do according to the stoichiometry, and we apply that if moles are equal, then their formulas will be equal and the answer will be calculated. So now students, we have our topic limiting reagent. What is limiting reagent? one day me and my brother were sitting and we were very hungry, so it was very late night time and my parents were sleeping. So I thought to eat something, and I went to the kitchen. I took my brother with me. I said, what do you want to eat? He said me, let's have some burger and all, you know. So but in the kitchen I observed, to make burger we need some buns, and we need some buns or bread, I would say, and along with that we need some salad to put inside it, we need some cheese to put inside it. So what we did was, we need some buns, and including other ingredients, we need these ingredients too. So to make burger we had only and only two burger breads, right? And we had ingredient in large quantity, but we were only two of the persons, but we were so hungry that we could eat 4 or 5 burgers, you know. So my brother said that I am very hungry, I want to eat more. So what did this situations explain us? That what is limiting reagent in this case? Limiting reagent is the one which is present in less quantity, and excess reagent is the one which is present in more quantity. So according to this, I would say that limiting reagent is the reactant which is completely consumed in a reaction. How I can explain you in the case of kitchen? See, if there are two breads, then only two burgers can be obtained, because bread is responsible, because it is in limited quantity, it will make only two. If breads were more and ingredients were less, then we could have done something more and made something different, food ingredients with us. But the bread was only two, then the burger produced will be only two, because it was the limiting reagent. That means limiting reagent is that reagent which decides that how much the product will be formed. Okay, now see, it is the reactant which is completely consumed in a reaction. Let us take an example. For example, I have 3a plus 4b gives 5c plus 60. Okay, and I am saying there are number of moles of A is 10, while number of moles of B is 20. See, in the previous case, only one situation was given, that was the 16 grams of CH4. And it was not given that what is the amount of O2 in it. Now, in this case, both of the reactant number of moles are given. How do we identify that? With the help of which we can calculate C and D amount. Now we need to find out from both of these reactant which is a limiting reagent and which is excess reagent. The one which is limiting reagent will help us to calculate the amount of substances of the product, right? So see, what happens is, this is the balanced equation which is given to us. Now what we need to do is, we see that 3a and here we see that 4b. We have reactant as 3a and we have another reactant as 4b. What is this? 3, 4, 5, 6. These are basically, students, these are basically the stoichiometric coefficient. What we do is, we calculate here number of moles by stoichiometry. And whose value is less is the limiting reagent. Now for 3a, number of moles of A is 10, divided by stoichiometry is the number in front of the reactant, it is 3. For B, the number of moles is 20 and the stoichiometry given here is 4. It is equal to 3.3 something and it is equal to 5. So which amount is less? Obviously this amount is less. This amount is less. That means it is limiting reagent. It is our limiting reagent which will help us to calculate the values of the product. Now I ask you, what is the amount of substance? What are the number of moles obtained of the product C? How can you calculate? Will you consider B now? No, because B is present in excess and we will find question only through the limiting reagent when two of the substances amounts are given to us. First we will find limiting reagent. How to find? Divide number of moles by stoichiometry, whose value is less, that is your limiting reagent. Now we have found this already. Now as you know that this is 3 moles, this is 4 moles, this is 5 moles, this is 6 moles, as we have done in stoichiometry. Now this will help us to find these, right? So I would say that 3 moles of A gives 5 moles of C, right? 1 mole of A will give 5 by 3 moles of C, right? So how many moles of A are given? 10 moles, right? So 10 moles of A will give 5 by 3 into 10 moles of C. Right? So by these we can find the number of moles. It comes out to be 16.66 value. So with the help of limiting reagent, we can calculate any amount of the substance of the products. Clear, students? Now proceeding toward one of the questions, let us see. Calculate the limiting reagent and the mole of product formed in the given reaction. We have H2 plus half O2 gives water. The first thing that we do is balance the equation, yet it is already balanced. Here in the reactant side there are 2H, here it is 2H, here O2 is 2 into 1 by 2 is 1, and here it is also 1. It is already been balanced. What we are given is it is taken 5 moles and it is taken as 2 moles, students. So what is the basic thing that we need to do is we need to divide number of moles by stoichiometry, number of moles by stoichiometric coefficient. Number of moles are 5 in this case. In stoichiometry, when nothing is given, it is considered as 1. That means it is 5. Now here, what is number of moles? 2. What is stoichiometry? Half. So it will go above and it will become 4. Now from both of these, which is present in less amount? Obviously this is present in less amount. That means it is referred to as limiting reagent. Now that means with the help of this we can calculate the mole of product formed in the given reaction. Now if we see, these are already given to us as half moles, and here it is 1 mole, the stoichiometry. So I would say half moles of O2 gives 1 mole of water. So 1 mole of O2 will give half mole of water, right? And in other terms, we need to calculate for 2 moles. So 2 moles of O2 will give half into 2 moles of water. That means how many moles of water are obtained? 1 mole of water is obtained. So by these you can calculate any of the questions. Clear, students? So yes, my dear students, this chapter is finished here. Hopefully you liked the video, you liked the chapter. Now the basic thing that you need to do is practice. Practice a lot of questions on the topic wise so that you can be perfect in every topic, in every aspect of some basic concepts of chemistry. I hope so that you like this chapter. Keep learning. Thank you so much. Have a good day.